Hello and good evening, everybody. Welcome to the 2020 Planet Party, brought to you by the Dunlap Institute for Astronomy and Astrophysics at the University of Toronto and the Royal Astronomical Society of Canada. We're very grateful to have so many of you listening along with us on YouTube. We hope you're going to stick around and enjoy the event. So just as we begin, I'd like to start with our land acknowledgement. We wish to acknowledge that the land on which the University of Toronto operates has for thousands of years been the traditional land of the Huron-Wendat, the Seneca, and most recently the Mississaugas of the Credit River. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we're grateful to have the opportunity to work on this land. And we're especially grateful today to have the opportunity to host this Planet Party. So I'd like to welcome everybody. My name is Michael Reed. I'm an astronomer at the Dunlap Institute in Toronto, in Canada. We know we have people joining us from all over the world. We're very thrilled to have you with us. So I'm going to tell you a little bit about what you can expect tonight, and then we'll get into the content. So normally at this time of year in Toronto, we would have a big outdoor event where we would welcome thousands of people to come to the heart of the city, and we'd partner with the Royal Astronomical Society to allow you to come and look through their telescopes and our telescopes, see all the great things you can see in the sky. Obviously, these days we can't do that, but we still want to share our love of the cosmos with you. So we're going to try something a little different this time. We're going to do this online. Now, we hope we've got this all worked out. A few of our presenters are a bit new to some of the technology, so we hope you'll be patient with them. Our big goal tonight is to get you to go outside and look at the sky. So we're going to do that by talking to you through the screen, but we hope if it's possible for you and safe for you that you'll consider taking your phone or your laptop or whatever you're watching on and maybe just going outside to the sidewalk, your balcony, backyard, wherever you are. If that's safe, try and go outside and have a look at the night sky. One of the things we're going to focus on tonight is trying to get you to find the 3 planets that can easily be seen with the naked eye today, which are Jupiter, Saturn, and Mars. So we're going to try and look at all of those. We've got some people standing by in different locations in downtown Toronto and also just outside the city where it's darker, where we'll try and stream views of the sky so that if it's cloudy at your location, hopefully you'll be able to see something a bit clearer. If that doesn't work, we've got recordings of last night when it was crystal clear. We'll also try and stream to you views of what the planets and the sky look like through our telescopes, again, located in different places. But we're going to do a lot more than that. We're going to learn a little bit about Indigenous astronomy and the constellations that are recognized by some local Indigenous cultures in the Toronto area. We're going to play some games, so I hope you're excited for that. You may have seen in the lead-in there, if you go to kahoot.it, you'll be all ready to go. People were asking in the chat if there's a PIN number. There will be, and as soon as the game starts, the PIN will pop right up for you. You'll be able to type it in and play along. We have some fantastic prizes that you can win. We've got some telescopes, some astronomical binoculars that you can win, some t-shirts, some moon globes, and for those of you who are joining us from internationally, because we're not able to ship prizes overseas at the moment, or at least we can't guarantee that, our prize for international participants is that you will get a one-on-one stream with an astronomer from the University of Toronto who will help you learn about how to use a robotic telescope network called iTelescope to take your own astronomical photographs, which should be a lot of fun. So that's what we'll offer for international participants. Now, we hope that you will, in the spirit of going outside, that you will actually do this tonight. Go outside, take a picture of your sky, see if you can find the planets when we show you how, or maybe you already know how. And you can take a photo of the sky. You can share it with at Dunlap Institute on Twitter, Facebook, Instagram, and you can use the hashtag PlanetParty2020. And from one of the participants in that stream of content, we will draw a winner and we will send you out a prize as well. So if you're interested in learning more about the prizes that are available, you can go to dunlap.utoronto.ca/planetparty. Or you can look in the YouTube video description below and there's a link right there for you. So we've got lots of great content tonight. As I say, we're going to have some people talk about different information about what's going on with the exploration of the planets these days. We're going to actually show you how to find things in the sky. We're going to play some games, lots of good stuff. Please feel free to interact in the chat on YouTube, but do remember, because there are people of all ages watching, keep the chat family friendly, please. Now, the very first thing that we're going to do is show you what's up in the sky tonight. And to do that, we're going to show you a free application that you can use. There's a web version of it. There's a downloadable version. We're going to show you what's up in the sky tonight. And I will emphasize that we know there's people watching from all over the world. Our main goal is to show you the planets, and anyone watching anywhere in the world can find the planets. The sky may look a little bit different where you are from how it looks in Toronto, but this program will allow you to look up what the sky looks like in your own area and find the planets according to your own local sky. So without further ado, I'm going to introduce our very first speaker. His name is Michael O'Shea. He is a graduate student at the Ontario Institute for Studies in Education here at the University of Toronto, where he studies access to education for Indigenous students. And he's also involved with an organization called PopScope. And during times when we are all able to go outside, he and his collaborators at PopScope take telescopes out onto street corners in cities all over North America and allow people to come and look through them. So although we can't do that tonight, you can go to popscope.org to learn more about their activities and when you might be able to find one of their pop-up telescope demos sometime soon, hopefully. So without further ado, I'm going to turn things over to Michael O'Shea.
Thank you so much. Thank you so much, Michael. I'm also Michael. Seems like Michael might be a popular name in the astronomy world. We're so thrilled to have you here calling in from all over the world. Unfortunately, we can't gather in person today, but in the spirit of astronomy, I'm glad we can come together separately, looking up together or looking at our computer screens together. And a big thank you to Dr. Reed, Michael, and all the folks that have worked so hard to put this event together. It's a real honor to be a part of it. As Michael said, I'm a PhD student at the Education School at the University of Toronto, and I also help run an urban astronomy group called PopScope. But enough about me. You aren't here to learn about me. You're here to learn about the night sky. And to do that, we're going to use a free piece of software called Stellarium. And you can access it online by going to stellarium-web.org. Again, that's stellarium-web.org. And as Michael said, we really encourage you to go outside if you can, if the weather's good, if it's safe. The great thing about Stellarium is you can use it on your mobile device as well. So go ahead and take your phone or your iPad, your tablet outside and look at the real thing in the night sky while we're looking on the virtual version here. So Stellarium, if you've been to a planetarium, it's much like that, but just a virtual version of that. And the first thing we want to do is to set the location to where we're calling in from all over the world. So you want to go ahead and set your location to where you are. To do that, click in the lower left-hand corner on the new what says Near Citizens Bank tab. I happen to be near a bank, I guess, in Boston, and turn off, in my case, I'll turn off use auto location because I want to set my location to Toronto just to demonstrate how this feature could work. So I'll zoom out here. You could also use the hourglass if that's easier over here. Type in your city, but I'll just drag it over here because I'm a visual person, and we'll set it to Toronto. We're in Markham, close enough, and we'll say use this location. And you'll see because Markham, near Toronto, is a little bit further west, the sky isn't quite as dark as it is here in Boston. The second great thing about this piece of software is that you can set it to any time, any date. In the lower right-hand corner, you'll see it displays the date and the time. So say you want to know what it was like last year at this time. Maybe you had an important day that day. Somebody started dating someone that day, or you started school. This will show you what the night sky looked like on this date a year ago. It looks like the moon was up, so that's nice. Let's go back to the current day. And if you're outside right now, I would suggest that you turn on your night mode on your phone or your computer. And what that'll do is it'll make everything look simply red. And that will help protect your night vision. So while humans can't look in the darkness, our vision actually does adjust to the night sky in about 20 minutes or so to dark conditions. Unfortunately, that night vision is pretty easily ruined by a bright light, like a car light or the blue light of a cell phone. But our eyes, that night vision is less sensitive to red light. So by making this red, you're better able to preserve your night vision. You'll see that the planetarium here is broken up to the 4 cardinal directions, and you can scroll. You can scroll through the planetarium by clicking on the screen and dragging. So north here, east, south, and to the west. And the wonderful thing about this stellarium is that you can see what's in the night sky even when it's cloudy, even when there's a ton of light pollution, which is the case here in Boston. Stellarium constellations. So let's go down here and click on constellations, and that'll display a little line drawing of what's in the night sky. Keep in mind, these are not the only constellations, that humanity has created or uses. These are just the Greek or Roman constellations derived from ancient Greek and Roman mythology. And today we'll actually learn of some indigenous astronomy knowledge as well. If these line drawings aren't enough, we can also add a more fanciful illustrated version here. And you can get an idea of what the ancients were maybe thinking of when they invented some of these constellations. But these illustrations won't help you find 2 of our targets tonight, which is Jupiter and also Saturn. So let's turn off the fancy illustrations here, and we'll get to our friend. It looks like I made a mistake there and turned off landscape. Let's turn that back on. And you'll see that Jupiter is in the constellation Sagittarius. If you're in a light-polluted city like I am, you may not be able to see Sagittarius, but if you're facing south, so try and find south, either using your phone or using a compass, and you'll see that there are 2 bright dots in the southern sky. And that's Jupiter and that's Saturn. What's terrific is you don't have to go and look up in an encyclopedia or go online to find out what Jupiter is all about. You can click on it, and it'll show you that Jupiter is very bright. It's negative 2.33 magnitude, which is a measure of the brightness of an object, and that it rose today at 4:30. It got up kind of late, and it'll go to bed kind of late too, around 1:30. You can also zoom in. So using your trackpad or using the scrolling function on your mouse, you can zoom in, and you'll see some of the atmospheric activity in this gas giant known as Jupiter. You're seeing all kinds of moons, too many to name here tonight. But importantly, the 4 brightest moons, the ones you'll probably see in a telescope, the moons that Galileo saw, Callisto, Ganymede, Io, and Europa. And they'll change from time to time, which is pretty exciting. Let's head over to our friend Saturn. You can zoom back out, jog on over to Saturn. So I seem to have lost Saturn, but that's not a problem. We can go to the search function up top, and we'll type in Saturn, see if that works. And that'll take us to Saturn. Some facts for you. And as we zoom in, we'll get an idea of what Saturn would look like through a telescope, even a small telescope, with its trademark rings. And also, you might be able to spot Titan, which is off to the side, and a pretty big object in the solar system as far as moons go. Dr. Reed mentioned you might see Mars later tonight. It's not yet up because it's too early to peak. If we advance the time just a little bit, and we will see our friend Mars rising in the east there, and it'll get higher and higher in the night sky. One last treat. if you're tired of those planets, look overhead. And even if you're in a light polluted city like I am, there's a pretty good chance that you'll be able to see the summer triangle. And that's formed, it's not a constellation per se, it's a pattern, but look overhead and you'll see 3 bright stars, Vega, Altar, and Deneb, forming a triangle to remind you that it was summer and we're soon moving into fall. So please go ahead and use this piece of software. Use it outside. Use it after we're done tonight. I wish you the best. I hope that you learn a lot throughout the rest of tonight's program. So without further ado, let me hand off this celestial baton to our next speaker, Mubdi, who is a terrific astronomer at the University of...
Hi, everyone. My name is Mubdi Rahman, and I am an astronomer here at the Dunlap Institute here at the University of Toronto in Toronto, Ontario, Canada. And we are broadcasting from various places here in downtown Toronto, a little around the area. Michael over there was based in Boston, and we're coming to you across the globe. So welcome as we start to get past the sunset and start to be able to see some of the planets, hopefully, if the clouds start to move across. I'm seeing a ton of people from all across the world. Shout out, I saw somebody coming in from El Salvador. This is we're excited to be able to bring the sky to you and especially show you some of the most incredible, exciting things that you can see often with your own naked eye. That's right. You don't even need a telescope, don't even need a pair of binoculars to see some of this stuff. And we're going to be showing you how to find them, as well as how to find some constellations all across. So stick around. It's going to be a ton of fun. If you happen to be taking photos, please feel free to share them on your socials, on Instagram, on Twitter, on Facebook, and use the hashtag PlanetParty2020. We love seeing all of your fantastic images. And secondly, please do follow us on Instagram, on Twitter, and on Facebook, and maybe down here in YouTube. Click the subscribe button. And there are going to be prizes for some of the photos that get shared on Instagram tonight. Secondly, I strongly encourage you to go out into, if you can, take your laptop, take your cell phone, and watch us while you're outside. And potentially, if it is dark where you are, you should be able to follow along with us, and that'll be a great experience to be able to, point out to your friends who aren't watching this, hey, I know how to find Saturn, I know how to find Jupiter, and I know how to find Mars. And you'll be able to pick that up anywhere you go. So that'll be a ton of fun. And so why don't we tune in to Mike Williams, who is over at the McLennan Physical Lab. So that is a building on University of Toronto campus where we have some telescopes set up. Mike, how's it looking over there? Mike, myself. I think you might be muted. Oh, there we go. Okay.
Hi, Mufi. Yeah, it's really, really cloudy here. So I'll just introduce myself. I complete the hat trick of Michaels in tonight's broadcast.
Triple Michaels. Yes, we had triple Michaels.
And yeah, I'm based down at the St. George campus, and I'm using our 8-inch telescope to hopefully look at Saturn. But we can look at the night sky right now. So this is a live view from the Toronto campus, looking downtown. So we're looking south. You can see the CN Tower, and there's a tiny little dot in the sky right there. That's the planet Jupiter. So it's really, really hard to see everything through all these clouds. So through the magic of time travel, we're actually going to go back in time to last night and see what it looks like.
The magic of the internet. Let's take a look. Yeah. Oh, wow. That is impressive. If only we had this technology for real.
Or a weather machine. I would rather have the weather machine. Just to pick out a few things in this sky, this really bright dot is the planet Jupiter. And then there's a slightly fainter dot that'll just be to the east of Jupiter in the sky, and that's the planet Saturn.
So Jupiter and Saturn.
Jupiter and Saturn. So Jupiter
in a smokestack as well. That's not as interesting.
Yeah, and a giant smokestack. Yeah, so Jupiter is actually the fourth brightest object in the sky after the Sun, the Moon, and the planet Venus. So it's really easy to find in the sky. If you've ever looked up and thought, there's a really, really bright dot there in the sort of southern sky, chances are it's probably the planet Jupiter.
So you heard it here first. If you see a really bright dot in the southern sky, it's probably Jupiter. Impress your friends if you head out and just say, hey, that's Jupiter. Generally, they probably won't be able to call you on it if it isn't.
Yep.
But on today's image, we're seeing that things were looking, those clouds were actually looking quite beautiful. They were looking kind of streaky. What's going on there?
Yeah, so to actually get a really nice image of the night sky, especially from Toronto where the sky is really, really bright, I'm actually taking a picture that's 4 seconds long, so you can see all the fainter stars in the sky. And so in those 4 seconds, the clouds will actually move and they look a little streaky. 4
seconds. So that's a lot longer than, say, if you just took a snap with your picture or with a cell phone or any of those things. That's typically like a fraction of a second, whereas you're doing it for 4 whole seconds.
Yeah. And your eye actually only collects light for about 1/20th of a second.
Okay, that's a really impressive that we can be able to do this. So this is it's not an exciting image, but a little bit of drama always helps with these kinds of sky watching experiences. This is what real astronomers go through on a regular basis. Oftentimes, we will be up at telescopes where we have been waiting to collect some specific data or some specific image of an area of the sky for years, and we will be clouded out. That is a real thing that we have to go through, and then we have to wait until the next opportunity to go to some of these larger telescopes. We actually have a question on the chat, Mike, asking what kind of camera or lens do you need to take these photos? Can you tell us a little bit about your setup?
Yeah, so the setup I'm using Canon 70D, so it's an amateur grade camera. And then I have a 14 millimeter f2.8 lens on it. So if you want to get the wider field, you need something sort of with a smaller focal length, like a 14.
Yeah. So that's not crazy equipment. That's the kind of camera that you might actually have lying around your home.
Yeah. So even the lens, the lens I bought is a Samyang, which is a really cheap Asian brand, which is actually quite affordable for the lens you get.
That's absolutely fantastic. Well, we're going to come right back to you in a bit. Maybe the clouds will clear up in that time, but let's take it over to Ian Wheelband, who is located about an hour away, or 100 kilometers or 60 miles, if you want to use that, north of Toronto. Ian, are you with us?
I am. How are you today?
I'm doing well, thank you. How's the sky looking where you are?
Well, I've just shared my screen. It's really not looking very good at all.
Ian, you're a little faint. Can we? I think your mic might be a little far from you at the moment.
How about now?
That is a little better.
Okay, I'll try and speak a little bit louder. Yeah, I'm clouded out, unfortunately. 60 kilometers makes a world of difference, unfortunately. So that's just the way it goes. Much like Mike downtown, I have this time machine called Video from last night. And this is what I saw with Jupiter last night from up close to Collingwood, Ontario.
So this is just, about an hour north of Toronto, where, you get a little less light pollution, though there's still some. And this is what you're seeing through your telescope last night. This is exactly what you're seeing through your telescope.
That's correct. This is a video stream off of an 8-inch telescope, totally amateur telescope, and it captures Jupiter reasonably well. Oddly enough, what you see through the eyepiece is often quite a bit sharper than you can get from a video camera, although we can do processing.
This is taking multiple images every second, and every single one of them, you can see Jupiter bright as bonanza right there.
Yeah, it's really, really very cool. It almost shines so brightly you can't see other things right afterwards. It's a very, very bright, pretty planet. That's for
That's
sure.
absolutely incredible. And you can see even the bands, those are real. Those are not because of the atmosphere. Those darker areas that we're seeing, that's Jupiter. That is, many millions of kilometers away. And we're seeing those big clouds.
The thing that I find interesting about Jupiter and Saturn is you can't actually see the surface, and there's not really a surface. So we are indeed seeing all the cloud belts only. And if you see my mouse, you can see a cloud belt here. This is another cloud belt with several details, festoons, and things bulging out into these equatorial areas. And last night,
by equatorial, you mean sort of along sort of the equator.
That's correct. Yes, and last night at 9:30ish, the Great Red Spot was right there at the end of my mouse. It's not there right now tonight.
What is this Great Red Spot you speak of?
Well, it's a very old hurricane, if you will, on Jupiter. 400 years ago, or roughly, when telescopes were good enough to start to see the surface of Jupiter, we noticed this red spot and figured out later it was a storm. So the storm has been going for at least 400 years, and today we can still see it.
So 400-year-old hurricane, that's what we're seeing from the Great Red Spot.
Yeah, and we get worried about 2 days long of hurricane.
So I wouldn't want to be anywhere close to that right now. Is Jupiter a place that you'd want to visit?
Not a chance. There's a moon of Jupiter called Europa that is lots of water perhaps underneath. I'd like to go there, but not Jupiter itself.
Well, we're getting a couple of questions actually about your setup. So how did you take this image? What kind of equipment are you using to take this image? Or this video, should I say? Video,
yeah. It's an inexpensive ZWO video camera. I think it was about $125.
125 Canadian, so that's like 20
Canadian.
cents American.
Pretty much. Now, the telescope is an 8-inch Cassegrain telescope, and it's mounted on an equatorial mount so that as the world turns beneath the telescope is able to stay centered on an object, whatever that might be. Last night it was Jupiter. So the equatorial mount, the Skywatcher HEQ5 Pro mount, and a ZWO 8-inch Cassegrain. QSO.
None of this stuff is super crazy. None of this stuff is super specialized, right? Like an 8-inch telescope is not the largest telescope in the world. You can actually walk into a store and buy one.
You can. I mean, an 8-inch Dobsonian mounted Newtonian telescope is probably one of the best ones to get started with. I know Chris is going to talk about that later. So yeah, 8-inch is not massive, but it can show some beautiful detail.
That's absolutely incredible. And just as a reminder, if you have the opportunity to be in a darker area that is cloud-free right now, and just go outside, you will see this as a bright dot. One of the cool things about planets is, unlike stars, they don't appear to twinkle. And one of the cool reasons for that is because planets are actually fairly large. They aren't just a point-like object. They're so close to us that we can actually see the disk. As in the image that Ian's showing us, we can actually, what astronomers refer to is resolve the planet, meaning that we can actually see what it looks like, whereas stars that are much further and further away, even though they're much larger, we can't resolve. So when our atmosphere gets in the way, for a star, it'll make it move around and shake and get brighter and dimmer, and that's what causes the twinkle. But a planet, because it's so big, all of that light that's coming through the atmosphere, it may shake a little bit, but because it's so big, it doesn't look like it's getting bigger or smaller or dimming. And so that's why planets don't twinkle. And you can actually see that right off the bat when you take a look at the night sky. So Ian, is it clearing up anywhere around you yet, or?
No, I think it's actually getting worse for me, unfortunately. So good thing that it was clear last night.
That is sorry, go ahead.
Oh, a couple other things you can just see in this video. Now, Jupiter is accompanied by many, many moons, 4 of which are easily visible, even in binoculars, and 3 you can see in this image last night. So there's one there, another one there.
Okay, they look a little faint on the stream, but you can sort of pick it out. So you might have to stare a little closer at the screen if you're watching from home, but they're there.
Yeah, Yeah, they are, and the live view from a telescope, they're like pinpricks of light. They're really quite beautiful and obvious to see. The other neat thing about it, I mean, like the planet itself, which rotates, these moons revolve around Jupiter. So come back an hour or two later, and they're in different places. Come back a day or two, and they're completely the other side of the planet. Sometimes it's a
So wait a
always
minute.
changing object.
You're telling me that these things can move in real time. Like you will see them actually change position.
Yes, in an hour a little bit, and in a day completely different.
Okay,
Jupiter
that's
itself,
mind blowing.
It is neat to think. You know what we look up and we see a static sky, and yet this kind of thing is changing all the time. Jupiter itself rotates so quickly that the surface details that we see here, they only take about 2 hours to cross from one side to the other. The whole thing takes about 10 hours to rotate, but we watch it, and the details will visibly move as you're taking an image of it.
That's incredible. And I completely agree with Dr. Duck in that you are a superhero for getting this video. This is absolutely fantastic. By the way, if you're just tuning in and catching up with us, this is the Planet Party, brought to you by the Royal Astronomical Society of Canada and the Dunlap Institute at the University of Toronto. And we are taking a look at footage of Jupiter. This is real video that is taken of Jupiter last night, unfortunately, because tonight we were a little clouded out. But Ian Wheelbid, who we have here, has so graciously taken this fantastic video that we've been watching, and this is real Jupiter. Those photons of light have traveled all the way from Jupiter, bounced in his telescope onto his camera, his video camera, and that's what we're seeing. That's incredible.
You know, I think you've touched on one of the things that I like the most when showing people through my telescopes is that they look and they come off the eyepiece and they go, oh my goodness, that was the real thing. And, you know, most people only get to see Jupiter either on a TV screen or maybe a book. But when you see it for real, it's fabulous. So the first day that it's clear and you can get outside and look for yourself, go for it, even if it's just with your binoculars.
So you heard it here first. Definitely go for it if you can take a look at it. Well, why don't we get back to downtown Toronto? Mike, let's go back to you. This is Mike Cubed, our third mic on the screen. How are you doing, Mike?
I'm good, Mukti. So what I'm showing right now is a live image from our 8-inch telescope up there. And yeah, so every now and then you just see this really, really faint thing just come into view. So that's Saturn trying clouds. But that's, you know, not all that interesting right now because it's not a really good view of it. So through the magic of time travel again,
the magic of the internet.
We can look at Saturn last night. So this is what Saturn looks like through
seriously, that is Saturn from last night.
Yep.
Like that's not a picture. You didn't just put your cell phone in front of the image or in front of the telescope and take a picture with that. No, that's a planet. That's a planet with a ring.
That's a planet with a ring. And one thing you'll notice is Saturn's kind of jumping around a little bit. And so that's due to what astronomers call seeing. So the path the light takes through the Earth's atmosphere changes a little bit over time. And so sometimes it'll shift it a little to the right, a little to the left, and sometimes it'll go completely out of focus. Because although it was clear last night, there was still really bad seeing.
But we're talking like this was downtown Toronto, like the place that you can barely see a few stars with your own naked eye, the place where like lights are always on, right? This is, you know, nearly as bad as New York City, and this is the picture that you got.
Yep. So, and Saturn's, I think, one of the coolest planets in the solar system. And one of the big reasons for that is the rings around Saturn.
That's right. That's a fantastic set of rings there.
Yeah, that is an amazing set of rings. But if you take all the mass in those rings and add it up together, the moon is about 1,000 times more massive than those rings. But the rings extend out to about 140,000 kilometers away from the surface of Jupiter. So they're massive, but there's not very much stuff in it. And it's mostly ice with a little bit of rock and stuff mixed in.
That's crazy. And something that's also worth pointing out is that this isn't just like Saturn's not producing light that we can see. It's not producing visible light. This is all light that's reflecting from the sun. So it's going past the distance of the Earth, hitting Saturn, and then coming back to Earth and landing on your phone or your telescope or your camera. Sorry, I know that you're not taking this with your phone.
So it travels a pretty fair way before it gets to us. And again, Saturn's just being kind of a giant mirror and reflecting the sun's light back to us. So every now and then, when it gets really clear, you'll notice that there's sort of a dark patch sort of around here, and it goes all the way around the rings. So that's called the Cassini division. And so that's actually a gap in the rings. And at least partly that gap is related to one of Saturn's moons called Mimas. So the particles in those rings go around Saturn 2 times for every 1 time that Mimas goes around Saturn. And that's what we call a resonance.
Right.
And so that actually affects the path of the particles, and that clears out a gap in the rings.
So basically, by resonance, you mean in this case that when you come around twice, that's when the rings will make 1 orbit around.
Yeah.
Or vice versa.
So the rings make 1 orbit around for every. It'll make 2 orbits around for every 1 orbit of the moon Mimas.
So it's basically, and it's almost perfect is the other thing to note. It's not like by chance. That is almost perfect. That happens to be the case. That's crazy. If you're just tuning in, by the way, we are taking a look at a video of Saturn that was taken last night from downtown Toronto with all its bright lights and all of its light pollution. And we're seeing it live as the light rays from the sun bounce off this majestic planet, travel millions of kilometers all the way back to Earth and make it into the telescope that we have here at the University of Toronto. And this is just astounding, Mike.
It is. And so just like Jupiter, Saturn has moons as well. In fact, right now, as far as we know, Saturn has the most moons out of any planet in the solar system.
So more than Jupiter, even though Jupiter is a larger planet.
Yeah, more than Jupiter. But that might just be because, we found more around Saturn. Jupiter might still have more.
Yeah.
So the limits of our own knowledge.
One of the crazy things about astronomy is that we constantly, there's a ton still to discover. But I see you changed over the image. What are we looking at now, Mike?
So now we're looking at a picture of Saturn and some of its moons. So unlike the video, I actually have to take a longer exposure picture so we can see the moons that are really, really faint compared to Saturn.
Okay.
So this giant bright blob right in the middle, that is Saturn. And then this right here is the moon Titan.
Right.
So Titan is actually the largest moon of Saturn. And
that's that fainter dot that we see just to the right of it, right?
Just to the right. So just to the right is Titan. And Titan is the only moon in the solar system that has a really thick atmosphere around it. And also, like Earth, it actually has liquid on the surface. It's not liquid water because as far out in the solar system as it is, the liquid would actually turn, like water turns to ice. Right. So the liquid is methane. And methane is
methane, like the kind of stuff that you get out of swamps. Like this is swamp gas, essentially.
Yeah. One of the major components in natural gas. So the thing we're using to heat our homes is just lying around in lakes and rivers on the surface of Titan.
That's crazy. But as a liquid.
As a liquid, yeah.
That's insane.
And so NASA's actually planning a mission to send a drone, so a flying ship that'll fly through the atmosphere in Titan. It's called Dragonfly. They expect to launch around 2026 and to have it get there by about 2034.
So 2026 to 2034. That's a bit of a trip. Personally, if I was going, I'd pack at least a few suitcases for that one.
Yeah. I hope Dragonfly has its Netflix up to date, so it can sit there and watch things for a few years. So it's ready to get there.
That's right. And Dragonfly, I believe, is a project that NASA is doing with the Johns Hopkins University, which, speaking of, in a few moments, we're actually going to have a lightning talk by a professor from Johns Hopkins University, Sabina Stanley, who is actually originally here from Toronto, who's going to tell us a bit about Jupiter. So we'll hear a little bit about those planets, as well as we will have CJ Woodford, who is a graduate student who's actually finishing up. He almost has his PhD at the Canadian Institute for Theoretical Astrophysics at the University of Toronto, who's going to be telling us about supermassive black holes. I've been seeing a lot of chat comments wanting to know about black holes. Well, this is going to be your opportunity. And just as a reminder, we're going to be coming back to both Ian and Mike throughout the night, as hopefully maybe the clouds clear up, or we can take a look at some of the images and videos that they took from last night, because you are here watching Planet Party 2020, our hashtag Planet Party 2020, brought to you by the Royal Astronomical Society of Canada and the Dunlap Institute at the University of Toronto. So we're going to move right over to a lightning talk by Sabina from Johns Hopkins University. Let's take it away.
Hello, everyone. My name is Sabina Stanley, and I'm a planetary scientist at Johns Hopkins University. In my research, I'm interested in all things about the interiors of planets. In this presentation, we're going to take a journey into the depths of Jupiter. How about we start by getting closer to Jupiter? There we go. Notice the brown and white bands that make up a series of east and west moving jet streams on Jupiter. The speeds in these jet streams reach over 360 kilometers per hour. The surface is also covered in giant swirling storms. The most famous storm is the Great Red Spot seen here. This thing is huge. Here's Earth for scale. The Great Red Spot is a giant hurricane. It's about 350 kilometers deep, and the fastest winds are on its outer edge and swirl at over 400 kilometers per hour. So what's it like inside the Great Red Spot? Let's dive in. Here we're flying over the cloud tops, approaching the Great Red Spot. These clouds are mostly made of ammonia and sulfur-rich compounds, unlike the nice water-rich clouds we have here at Earth. The scale on the left shows the altitude as we get closer and closer to the cloud tops. All of these images are from the Juno mission, which is orbiting Jupiter right now. Once below the cloud tops, we get an artist's rendering of what it's like here. The temperature increases to over 200 degrees Celsius by a depth of 200 kilometers. That's a common feature we see about planets. They get much hotter the deeper you go in. We'll see how hot it gets at the center of Jupiter in a little bit. As we emerged back from the clouds, we now get a nice view of the Great Red Spot while hovering just above. The winds and jet streams we see here are somewhat different from what we see at Jupiter's poles. We didn't actually have a good look at Jupiter's poles until the Juno mission started orbiting Jupiter from pole to pole back in 2016. At the North Pole, Juno scientists found an amazing sight. 8 giant swirling hurricanes surrounding a central vortex at the pole. This image was made from data using Juno's infrared cameras. They can sense the temperature of Jupiter's atmosphere. In a gaseous planet like Jupiter, warmer regions of the atmosphere are deeper than colder regions. So we also get a sense of the shapes of the clouds from the temperatures. Yellow regions in this image are hotter and deeper than red regions. Each of these hurricanes is about 4,000 kilometers wide, which is about the distance from Toronto to Vancouver. Clearly, the weather is quite stormy in the polar regions of Jupiter. But what about deeper in Jupiter? What's going on here? One question we might ask is how deep the jet streams at the surface go into the planet. Juno gravity data has shown that the jet streams extend down to about 3,000 kilometers deep. On Earth, that would take you almost halfway into the planet, but on Jupiter, it's only about 5% of the planet's depth. But what's under the atmosphere? Jupiter is mostly made of hydrogen, but that hydrogen experiences higher and higher pressures and temperatures as we move further into the planet. Now, when you squeeze hydrogen to high enough pressure, it eventually changes from a molecular gas to a liquid metal. Before the Juno mission, it was believed that Jupiter must have a small rocky core at the center of the planet. This was based on how we think planets form. But Juno data has shown us that this picture isn't that simple. Jupiter appears to have a fuzzy core. That is, rather than a separated rocky interior, the rock and metallic hydrogen mix deep in the planet. Scientists think this might have occurred from an Earth-sized planet impacting into Jupiter and mixing up some of its interior. Now, this would have happened very early in the solar system while all the planets were still forming. Another possibility has to do with the high pressures and temperatures at Jupiter's center. At pressures of tens of millions of atmospheres and temperatures of tens of thousands of degrees, hydrogen and rocky material might chemically dissolve into each other. There are still many questions about Jupiter, and lots of scientists are working to answer them. As we get more data from the Juno mission and from future missions, we look forward to learning more about this beautiful giant planet and about planets in general. If you want to learn more about Jupiter and the Juno mission, I recommend Googling Juno and Jupiter and check out some of the NASA-related sites. Thank you.
Hi folks, I hope you're enjoying the Dunlap Planet Party so far. My name is CJ Woodford. I am a graduate student here at the University of Toronto in the Department of Physics, as well as at the Canadian Institute for Theoretical Astrophysics. And I'm here tonight to talk to you about Sagittarius A star, the supermassive black hole in the center of our galaxy, the Milky Way. So we're going to answer two main questions about Sagittarius A star. We're going to ask, where is it in the sky? Can we see it? And also, how do we know it's a supermassive black hole? Could it be something else? So without any further ado, let's jump right in. So the first question is, where is Sagittarius A star? And I'm actually using a tool that you've probably already been introduced to during the Dunlap Star Party tonight, which is Stellarium. And in particular, I'm using Stellarium web version. And we're looking at the sky, as you would see from Toronto, at 9:15 p.m. tonight on September 12th. So this should be something very similar that you have up already, or something that you're able to see in the night sky with binoculars, your eyeballs, or a telescope if you're fortunate enough to have one of those. So looking towards the south in Toronto, we see the constellation Sagittarius right underneath the planets Jupiter and Saturn. From the name Sagittarius A star for this supermassive black hole, it's probably not surprising. It's in and around the constellation Sagittarius. It's not quite in the constellation. It's actually between Sagittarius and Scorpius, and right in the center of the Milky Way galaxy. So even though we know where it is on the sky, and it is visible, certainly, especially here in Toronto or the Greater Toronto Area, certainly visible tonight, you can't see the black hole itself. And there's two reasons for that why we can't see Sagittarius A star. One, because it's a black hole, and two, because it's in the center of the Milky Way. So why is the center of the Milky Way a problem? Well, there's a lot of gas and dust between us and the center of the Milky Way galaxy, and optical light, the kind that you would see with your eyeballs, binoculars, or telescopes, gets obstructed or stopped before it reaches us. The other part being a black hole is that, well, gravity around black holes is really, really strong, so much so that nothing can escape, not even light, of pretty much any kind. And so that's also why we can't see Sagittarius A star directly. So in the center of the Milky Way and also a black hole means we can't observe it directly. So if we can't observe it, how do we know what it is? How do we know it's a supermassive black hole and not something else? And that's our next question. How do we know Sagittarius A star is a supermassive black hole? And the first reason is how nearby stars move. So even though we can't see Sagittarius A star directly, we are able to see some of the stuff around it, some other objects in the center of the Milky Way galaxy. And we have a pretty good understanding of how things move and how things orbit, and especially how they orbit around black holes. We have really good ways of describing that. So taking measurements of the motions of stars in the center of the Milky Way shows us that the stars are moving very, very close and also moving really, really fast around this central object, Sagittarius A star. And from those observations, what needs to be there, what Sagittarius A star must be, is about 4 million times the mass of the sun, but only 10 times as wide. So think about that for a minute. 4 million times as massive, but only 10 times as wide. That's a very compact, dense, extreme object, and the only thing that that could be is a supermassive black hole. So that's the first argument. The other reason why we know is by looking at how nearby matter interacts. And this does have a little bit to do with how it moves, but thinking about things instead of stars like gas clouds. So this gas cloud, these observations, again, bottom right-hand corner showing you the year, so we've already seen some of this, goes around Sagittarius A star, it gets superheated, rips apart, some of it's going back in and falling on the black hole. There's lots of chemical reactions happening in that gas cloud now that we are now able to observe and see from Earth. So all of that stuff also informs us that this is a supermassive black hole, how it was ripped apart, how much it's superheated, and the types of interactions that are happening inside that gas cloud during that interaction. So what did we learn? Where is Sagittarius A star? Between Sagittarius and Scorpius on the sky, those two constellations, as well as in the center of the Milky Way galaxy. How do we know Sagittarius A star is a supermassive black hole? Well, we look at how nearby stars move, as well as how nearby matter interacts, like that gas cloud that gets ripped apart. Of course, this doesn't tell us everything about Sagittarius A star. There is still lots to learn and more to discover. And so there's constantly being observations of the center of the galaxy in Sagittarius A star, like from Keck and Chandra. And the Event Horizon Telescope, the same telescope that took a photo of a black hole last year, is trying to take a photo of Sagittarius A star, the one in the center of our galaxy. I didn't answer all your questions, I'm sure, so please have a look at this resources page. The link to the slides is going to be in the chat as well as in the description, and then these resources will also be available. Thank you for tuning in. I hope you have a great night. Enjoy the rest of the Dunlap Planet Party 2020.
Hi, everyone. My name is Dr. Ilana McDonald, and it's the moment you've all been waiting for. It's the game section. Hooray! So I work at the David A. Dunlap Department for Astronomy and Astrophysics, and I'm going to be your games hostess today. This is the first of three rounds of games that we'll be hosting during the Planet Party. And for each round, we'll have prizes for the top 3 scorers, as well as one randomly selected participant. So if you're playing tonight, you could possibly win a prize, even if you're not one of the top three winners. So in a moment on your screen, you will be able to see a big number. And if you want to join in on the games, you should go to Kahoot.it. That's KAHOOT.it, and you can enter the game pin that you see on the screen right now. So if you're watching the live stream on YouTube, which you should be, I'd recommend getting a different device or using a different browser window than the one you're watching on the stream, as the questions won't actually appear on the device that you're using to answer the questions. And then once you enter this pin, you'll be prompted to enter an email address. Now, I understand that sometimes you don't want to give away your email address. Just enter some random letters, but know that you'll only be able to get a prize if you enter your correct email address. So if one of the top 3 winners, for example, doesn't have a valid email address, then we have to pass it down to the next top scorer who does have a valid email address to get your prize. I'd also like to note that you can only win once during the stream. So if you place in the top 3 during more than one round, we're going to award the prizes to the next highest scorer on the list. So as Mike Reed said at the very beginning of the stream, we're only able to ship our prizes to Canadian participants outside of Quebec. International and Quebec participants who win one of the top 3 spots, you'll be eligible to get a one-on-one tutorial on how to take an astronomical picture using the iTelescope network with a real astronomer. So keep in mind that while you're playing the game, there is a couple of seconds delay between what I'm seeing and what appears on the stream. So be sure to get your answers in quickly. You'll have 60 seconds to answer each question, but you'll get more points the faster you answer. So speed really counts in this case. So now that we've gotten through all the formalities, let's get started. And just keep in mind that if you're joining a little bit later, you still have a chance to join this game because I won't be locking it. So let's get started. The first set of questions. So here we are using Kahoot, round 1 of our Planet Party games. And before we get started, there is in fact something I want to show you first, which is our prizes. So these are the prizes that you can win if you're one of the top 3 scorers for round 1. In first place, you can get a Power Seeker telescope, which is a beautiful little telescope you can use to view the planets and the stars. Really fantastic. We have a Chime Lego set, which was custom designed for the Dunlap Institute, so it's very, very cool. And in third place, you can get a Dunlap Institute t-shirt, which is very attractive. And one randomly selected participant will be getting one of those moon globes, which if you were watching at the very beginning of the stream, that was that beautiful little moon lamp that you saw behind Mike Reed. All right, let's get started with our very first question. So get ready to answer this. How many times could the Earth fit inside of Jupiter's Great Red Spot? Now, if you were listening earlier in the stream, you might have heard the answer to this question, but let's see how you do. So we've got several hundred answers coming in. Amazing. You've got about 40 seconds left to answer. So there you have a beautiful image of the Great Red Spot on Jupiter, and the question is, how many times could the Earth fit inside it? Is it 2 to 3 times? Is it 7 to 8 times? Is it over 10 times? Or is that it wouldn't fit inside because our planet is too big? So we've got about 15 seconds left. Get those answers in. All right, here we go. 5, 4, 3, 2, 1, and let's see how you all did. So yes, the answer is, which most of you got right, fantastic job everyone, is 2 to 3 times. So as it turns out, our entire planet Earth would fit into this spot 2 to 3 times. And as we heard earlier, it's a giant hurricane that has been around for hundreds of years. And fun fact, Jupiter is the largest planet in our solar system, and the Earth would be able to fit inside this giant planet over 1,300 times, which is a lot of times. It's a very big planet. Let's go and see how we're doing on the scoreboard. So you had a random name assigned to you at the beginning of the quiz, and it looks like Magic Snail is in the lead, though quickly followed by Bright Panther and Social Wallaby. Let's see if everyone else can catch up in the next question. So here's our second question of the night. Which moon of Jupiter has large amounts of liquid water under its icy surface? And if you were listening to Ian earlier, you might have heard the answer to this question. So is it Io, is it Europa, is it Ganymede, or is it Callisto? To help you along, we have a picture of all 4 of those moons of Jupiter. You've got about 40 seconds left to answer this question. So which is the moon of Jupiter that has large amounts of liquid water under its icy surface? And we've got about 20 seconds left. 15 seconds left. Get those answers in, only about 5 seconds left. And we're out of time for the second question. So, which moon was it? It's Europa, which again, most of you got correct. I'm so proud of you all. So, yes, Europa is a moon of Jupiter that has huge amounts of liquid water under its kilometers thick icy surface, and it is the second farthest of Jupiter's Galilean moons, which you could actually see through a telescope if you looked at Jupiter. Let's see how our scoreboard is doing. It looks like Mighty Dog has moved into the lead, Noble Ant following close behind, and then close behind that, Great Finch. Let's see how you do on the next question. So now you have to type in a number. How many known moons does Saturn have? So type in that answer. Type in a number. How many moons does Saturn have? Or at least that we know about. 45 seconds left. So here you can see an image which was taken by the one of the Voyager probes of Saturn with some of its largest moons. And there may be a couple more there that we can't see. So there's probably a bit more than in this image. So you've got about 20 seconds left. Make sure you get your answers in quickly. Remember, speed counts for these questions. And 5 seconds left. 4, 3, 2, 1. Let's see how you did. So we got a lot of answers, but the correct answer, which 232 of you got correct, is 82. So yes, Saturn has 82 moons that we know of, which is the most of any moons in the solar system, or of any planet in the solar system. But we're discovering new moons around other planets all the time. So there could be another planet that has more moons, like Jupiter, for example. All right, let's take a look at that scoreboard. It looks like Captain Hare has moved to the lead, followed by Green Buffalo and Lively Turtle. So good job to you. Let's go on to our next question. So for our fourth question, in which constellation was the first black hole detected? So was it Lyra? Was it Cygnus? Was it Ursa Major? Or was it Sagittarius? So which constellation contained the first black hole ever detected? And in this image, I'll notice the seconds tick by. This is an image of the summer triangle, which is in fact visible tonight if we get some clear skies a bit later. 20 seconds left. Get your answers in quickly. $15 seconds left. All right, 7, 6, 5, 4, 3, 2, 1. Get those answers in. And time is up. So the constellation that the first black hole was detected is in fact Cygnus. Many of you answered Sagittarius because that's where the supermassive black hole at the center of our Milky Way is located. But it was, in fact, the constellation Cygnus. It was an X-ray source called Cygnus X1. Let's go on to our final question of this round. But first, let's see how our scoreboard is doing. We've got Quick Koala in the lead with Royal Pony and Dr. Rabbit very close. We've got one final question. Let's see how you do. So besides Saturn, which planet in our solar system has a system of rings? So is it Jupiter, is it Uranus, is it Neptune, or is it all three? So get those answers in. Which other planet besides Saturn in our solar system has a system of rings? So is it Jupiter, Uranus, Neptune, or all three of those planets? So we've got about 30 seconds left. Get those answers in quickly. Here we have a nice composite image of all the planets in our solar system, taken by various spacecraft that have traveled through our solar system. All right, about 8 seconds left. And our time is just about up. Let's see how. So the answer is all three. So Saturn has a beautiful set of rings, which we got to see earlier, but all four of the Jovian planets have some sort of rings. But some of them are so faint that you can't actually see them with the naked eye. You have to get really close up to them to actually see those sets of rings. All right, let's check our final scoreboard. Let's see who won this round. So in third place, we have Nimble Panther. Congratulations to you. In second place, Royal Pony, and our grand prize winner for the first for this first round is Quick Koala. Amazing job. That was our first round of games. Congratulations to our top 3 winners and our all of our participants for this round. Remember that if you put your correct email address into Kahoot, you're eligible to win a prize through our random draw. So thank you all for playing, and I'll see you all for round 2. So next up, we have Thomas Deere, who is from the Mohawk Wolf Clan, Haudenosaunee Iroquois Confederacy, who will help us learn about Indigenous astronomy. So enjoy that, and I'll see you again for round 2.
Hello. What's going on? This is Wagwego. I ask you Wagwego is what I got it then you. Because the news is what I'm so they can not that work hard. Good evening, everyone. My name is Thomas Deere, as you just heard. I'm a Mohawk from the Haudenosaunee Iroquois Confederacy, belonging to the Wolf Clan. And I live on the Six Nations First Nation. We're approximately 100 kilometers west of the city of Toronto. And currently it's overcast as well here, so we can't see too much of the night. So what I'm going to talk about anyway is, as you see in the picture, the constellation known as the Big Dipper, or the Great Bear constellation. In our language, in Mohawk, we call it Okwari-Gowa. So that's what I'm going to be talking about, the origin of that and what it means to our people. So I guess just to share a little bit about our people and the Six Nations. Historically, you would have seen, or you can see in the picture if you look at, starting on the right-hand side, that is the traditional style of headdress that our people would have worn, of the Mohawk people. It has 3 feathers standing up, and you may be able to see it when I come back on screen. There's an example of that over my right shoulder. And as we move towards the left side of the figures on top of the building there, we have the Oneida people. They also have 3 feathers on their Gostowa, on their traditional headgear, with 2 feathers pointing up and 1 pointing towards the back. As we continue moving towards the left, we now have the Onondaga people, who have 2 feathers in their traditional headdress, with 1 feather pointing up and 1 pointing down. And as we continue moving towards the left, we now have the Cayuga Nation with 1 feather. And then as we move left again, we have the Tuscarora Nation, who doesn't have feathers standing up, but they have feathers that are split down the middle and attached to the headdress. And then the last one, the final one on the end, is the Seneca Nation. And as you can see there, they also have 1 feather standing up. So some of the stories that we have are common to all of our people. We live together in one confederacy, and so many of our stories are very similar. So the story that I'm going to talk about, the origin of the Big Dipper constellation, is something that is similar to all of our peoples, all of our nations, the 6 nations of our confederacy. And so this story talks about a bear. So at one time, many years ago, hunters who were brothers, and they were very good hunters. They were so good that it didn't matter when they started to hunt something, they were able to track it and follow it. And once they started tracking something, they were always able to catch up to it, to find it. It could never escape from them. And one day, when the cold nights came, there was a bear that came And this bear was so large and so powerful that many thought it must be some kind of a monster. It appeared, and many people in the village whose hunting grounds where this monster bear had been were afraid to go there. This bear had invaded their hunting territory. It had gotten to the point where the children were no longer, they were afraid to go outside to play into the woods, because at that time this bear would attack people, and many people were killed by this bear. And their longhouses, the type of house that they lived in that you saw earlier in a picture, were guarded by many of the men to keep this bear away during the night. But each morning when the people went outside of the villages, they would find the huge bear tracks that had circled around in the middle of the night. And they knew that this bear was beginning to be more bold and would come closer to their villages. So these 4 hunters then were called upon to go and hunt this bear and to stop it from molesting the people and chasing the children out of the forest and chasing the people away from their hunting grounds. Many people were starting to become hungry because of how this bear was chasing people away and was so fierce and vicious in its character. So these 4 hunters then went out into the woods and started to look for this giant bear. They started to look for signs. But every time they would go out, when they would start to track the bear, it would only go so far and the tracks would disappear. One day while they were trying to track the bear, they found a great large pine tree, and they found the scars on the tree where the bear had scratched on it and left deep gouges up into the tree. The tallest of the brothers tried to touch the highest part where the scratch marks were on the tree, and he used the tip of his spear. That's how far up into the tree the scratches were, which showed how large the bear was. One of the brothers commented and said that it was just as we feared, that this great bear, the one that we call Okwarigowa, the great monster bear, and that this monster bear had a certain kind of power and a strength. Some might say that it was magic. So the brothers then decided that they would try to do their best to follow this bear and to catch it and to stop it from hurting the people. So the 4 brothers then continued on. They all agreed that they would do whatever they could. They would try their hardest to chase this bear and to catch it and to stop it from hurting the people. One of the brothers, though, was very lazy. And whenever they would go out and to start to track the bear, he would start to complain when it was getting to be too difficult, when the land was getting to be difficult, when they were going through the deep woods and the ravines and climbing over hills and mountains. But nevertheless, they continued on and they persisted, even though he complained. They carried on as far as they could. Finally, one day, as they were walking through the woods trying to track the bear, they had their little hunting dog who was with them. And in those days, they said that when you had a dog, and if it had the black spots over its eye, that dog was also a good tracker. And so their dog then continued and ran ahead of them to track the bear. Finally, after many days of walking and tracking the bear and trying to find its tracks when it would disappear, finally their hunting dog caught its scent and was able to then help the hunters to find the bear. They found his trail and found his tracks, and they were able to very carefully. But as they got close to where the bear was, they started to see that this bear was a white bear, and that it was a very huge, immense size that they had never seen before. And so they started to chase it, even though they had sort of become afraid. They started to chase it to try and stop it from molesting the people. And the bear started to then run away. And as it ran, the hunters with their dog chased it as quickly as they could. They tried to stay as close as they could behind it. And they didn't notice, but the bear then, as it started to run, rose up into the air. And as it went higher in the air, the brothers followed it. And as they would get closer, they would then use their bows and their arrows, and they would shoot it towards the bear. And some of the arrows would hit it, but none of them would stop the bear. Some blood would drip. But they continued on, and they continued to chase it. Finally, one of them took a great aim with his bow and shot at the bear. And finally, they were able to stop it and finish it off. So at that time, then, the lazy brother, who had run ahead and killed the bear on his own, he then took his implements that he used, and he started to skin the bear and to take the meat and to put it on a fire. And the fat that dripped from that meat as he was cooking it, it dripped onto the trees below. It was only then that the hunters noticed that they had rose up into the sky and had been chasing the bear through the heavens. And so they're cooking the meat from the bear. They noticed that far below was where the earth was, and far below was where the people were. And they realized that they had followed the bear up into the sky. And so the brothers then put their thoughts together. And as they were sitting there talking, wondering what had happened and how did they end up into the sky, they noticed that where the bones that they had taken from the bear and had piled them off to one side started to move. And the bear magically started to come back to life. Its body reformed, and it started to run again. And so the hunters then continued and started to chase it again, with the understanding that if they didn't, the bear would come back to the earth and molest and hurt the people again. And so they continued on in the chase. And so our people say that every year, this bear and these hunters run through the air, run through the sky, and run through the heavens. And we use that as a marking of time. Today we call this a constellation. The hunter and the bear turned into what we know as today, Okwarigowa, or in English what's known as the Big Dipper. And as you can see in the picture, this is how our people visualize this. So what is known as the Dipper part of the constellation is the bear, and the stars that are behind it are the hunters coming behind, chasing it. And as it goes through the year, we can see that the constellation turns and it changes. We can see that the Great Bear, in the summertime, the Great Bear begins to, if you look at the top of the slide here, the Great Bear begins to turn over and rise in the spring. And then as we go counterclockwise, the Great Bear is followed by the hunters. He begins his descent to the earth in the summertime. And then at the bottom, the hunters chase the Great Bear into the sky and eventually finish it off in the fall. And then the next part is when the Great Bear is dead and turns upside down in the wintertime. So that's how our people look at the constellation throughout the year. They understand that story. So right now, we're at the time where the hunters are chasing the Great Bear through the sky in the fall time. So at the end of fall, that constellation will start to go back up into the sky and start to turn over. Right now, in the evening, about this starting to now run along the horizon, and it pretty much looks and follows just the way that the story says. The bear runs along the horizon in the evening, and as morning comes, it starts to go back up into the sky. So our people also used to use this as a way to navigate how they were traveling. At one time in this country, it was covered by a great forest, and our people traveled through that forest, and all they had was the understanding of the constellations and nature and how to navigate their way around. So the Great Bear, followed by the hunters, helps us to find our way home by showing us where the North Star is throughout the year, which would then help us to find our way back and to help us navigate where we were when we were traveling through this vast continent of forest at one time. So you can see in the slide there, that shows how you can use the Big Dipper constellation to find the North Star, or what's known as Polaris. or in our language, which is Stadogan, the star that never moves. And so today we still tell that story, and we still remember, we still use it as a marking of time, and we use it to help us to determine when our hunting season will begin, because at this time of the year, we have to start to hunt because we are celebrating the harvest of our gardens that we've planted, our staple foods, the corn, beans, and squash. And we use the meat from the game animals to help to flavor that. And so we still use the constellations today to help us determine when that hunting season would begin. And so that's as far as I can go to tell you the story of the Great Bear constellation. And so I hope that you enjoyed the story, and that when you look up into the sky, remember that at one time this country was traveled by our people, Mohawk, Oneida, you've heard the Huron, the Wendat, the Seneca, all of those people. And these are the stories that for thousands of years they told their children and their grandchildren to help them to live their lives in this country we now call Canada. And so I hope that you can remember some of those things, carry on this knowledge, this history that was born and comes from the original people who inhabited and still inhabit this country known Canada. So with that being said, I'd like to say Nyawe. That means thank you to everyone for listening and hearing my story. And I think that's about all the time that I have. And I'll turn it back over to our host. Thank you very much, Nyawe.
Okay, thank you so much, Thomas. We're very grateful to you for sharing your knowledge with us. It's always a very special privilege to hear astronomical knowledge from an Indigenous person, especially live on stream like this. We're very grateful to you. So for those of you who are following along with us, or maybe just joining us from home, this is the Planet Party 2020. We have a bunch more exciting content coming up for you. One of the things that's coming up in just a few minutes is our live question and answer period with 3 astronomers. But before we do so, get your questions ready, and you can consider putting them in the chat now if you like. But before we do that, we're going to hear from Jenna Hines, who is from the Royal Astronomical Society of Canada, who's going to tell you a little bit more about, if you're thinking about maybe taking a photograph of the sky, a little bit about how you might go about doing that. So I'll turn it over to Jenna.
Hello everyone, I'm Jenna. I'm the Outreach Coordinator at the Royal Astronomical Society of Canada. The RASC is a big amateur astronomy club that spreads all the way across Canada. We have 30 centers and almost 5,000 members, all of whom are just really interested in space and absolutely love going out to look at the sky. The best part about being a member is that no matter what you're interested in when it comes to space, there's almost guaranteed to be another person there who's interested in it as well, be it astrophotography or actually going out and observing, or even space law. We have so many members and so many passionate people that it's almost guaranteed you'll meet someone else who shares your passion. I'm relatively new to astronomy. I've only been interested in astronomy for about 3 or 4 years, and I only just started getting into astrophotography earlier this year. So I wanted to share with you a couple of techniques that you guys can go out and try on your own next time it gets clear outside. One of them just requires either a DSLR or a phone, but primarily a camera that you can change the settings on, and then the other does require a telescope. So I'm going to go over those 2 with you right now. So I've got my camera here. It's an Olympus, but all you really need is a camera where you can change the settings like shutter speed and ISO and aperture. Sometimes phones will let you do this as well, so you can do this with your phone if it has that kind of settings. If not, you can download, and you can usually download an app that allows you to make those adjustments. And I'll list a couple of them here that you might be able to download. So first off, I wanted to give you guys some settings to get started. When you're taking, this is going to be a photo of the whole sky. So a nice wide field picture with maybe capturing the Milky Way or some constellations. So some basic settings to get started would be, let's try a photo at somewhere between 20 and 30 second exposure with an ISO somewhere between 1600 and 3200, and finally an aperture as wide as possible. So in this case, mine can go up to 2.8. And so I'm going to set my aperture at f2.8, but if you're using a phone, you might not be able to get that low, or if you have a different lens, it might be a little bit higher. It might be like f5.6 or something like that. Start with those settings. One last tip, before you go and take your photo, make sure to put on the 2-second timer. So then when you press the shutter, the camera has 2 seconds to stop jittering around after you've pressed it, and then it'll take a nice clean picture. So right before you take the photo, the last step that you're going to want to go through is to focus the camera. So find the spot on if you have a zoom lens, find the spot where you're going to be taking the photo, and then find a point of light somewhere on the horizon. Usually it's like a street light or something like that. Bring it up in your viewfinder, and then focus the camera in manual mode so that that little point of light is as pointy as possible. The blurrier it is, the more out of focus your picture will be. And you want it to make sure it's on the horizon so that it acts like the stars, in that it's really far away. Once you have that focus set, don't touch it. Just put it either on your tripod, which is what I've got here, and I'm doing a terrible job of it. Put it on your tripod, or put it in like some rocks or something that's solid, and make sure that it's all set and ready to go. And then once you're ready to go, press that shutter button. There'll be a 2-second pause, and then the photo will start to take. If you're where I am right now, I can't move because this deck is a little wobbly, and if I move, the stars in the picture will be wobbly too. So make sure that you're on a nice solid ground, like a concrete pier or, actual ground when you take this photo. But that's all you need to do. You can do it with a DSLR, you can do it with your phone if your phone has the ability to change those settings. So here's a photo that I took using the same method before I processed it and also afterwards. So don't forget as well that Photoshop and GIMP and other photo editing softwares are your friend here. Don't forget to edit your photos. Now, this is good for those wide field pictures where you can see the whole Milky Way. But let me show you another technique for capturing planets and the moon. This one needs a telescope. So for this one, all you need is a telescope and a phone and steady hands. So you'll want to get the telescope set up and ready to go, pointing at something cool. So in this case, it would usually be Mars or a planet or the moon because they're pretty darn bright. Once it's all set up, you'll have the eyepiece in and everything. All you have to do is balance the phone carefully over top of the eyepiece. And then you can take some pretty cool photos that way. It does require a steady hand because you have to balance in 3 dimensions. And there are tools that exist to make this easier for you. I have one of them. The more advanced version is called the Stellarium XYZ. And that allows you to adjust, or it basically holds the camera or your phone in position. And so you can just slide your phone in, line up the camera with where the eyepiece is going to go, and attach it directly onto the eyepiece like this. Once it's attached, your phone stays steady. You can find that position that works, and you can take multiple photos. You can move the telescope around and find other things, and then that allows you to take pictures, especially of the bright objects. So the moon, Saturn, and Jupiter are all perfect in this, and actually with the opposition of Mars coming up in the fall, it'll also be a spectacular way to take photos of that. Now, I hear what you're saying. Not everybody has telescopes. Almost everyone has a phone, but not everyone has telescopes. So your solution for that is to join the RASC, because many of our centers actually have telescope loan programs. It's one of my favorite parts about membership is that you can actually just borrow telescopes from the library that the center has. Not every center has this, so do check. But for example, Toronto Center has a telescope loan program where you can borrow a telescope for a couple weeks, try it out, see if you like it, and then give it back. It's perfect for if you, first of all, don't want to buy a telescope. Second of all, don't know what telescope to buy because it allows you to try multiple ones. And it's also a much more affordable option for looking at space because RASC memberships are usually less than $100 for the year. And so it allows you to get, some pretty cool pictures and see some pretty cool stuff in space just for the cost of the RASC membership. There's lots of other great stuff too. For example, Toronto Center is hosting a beginner astronomy course called NOVA, which is going to be happening online in the fall. So if you would like to check that out or sign up, first of all, you can check their website, rascto.ca, or you can sign up for our newsletter here at rasc.ca/newsletter. And that will go out every Monday. It tells you everything that's going to be happening in the RASC that week. So sign up, join us as members, come and hang out with all of us space nerds, and we'll see you soon. Hope you get some good photos.
Hello, everybody, and good evening. I hope you are enjoying Planet Party 2020. My name is Kara Manovich. I am Events and Outreach Officer here at the Dunlap Institute. I am so excited to have three wonderful astronomers with me. I have Emily Diebert, I have Ayushi Singh, and I have Dr. Jing Le. So here we go. Without further ado, put your questions in the chat and let's ask our astronomers anything. So we have a few questions, and for our panelists, feel free to jump in anytime. Someone is asking, is the universe always expanding or is it staying the same size?
I can jump in right now. Oh, or if you want to. Okay, yeah, I'll just give a quick introduction of myself as well. So like Kara said, I'm Emily, and I'm a fourth-year PhD student here at the University of Toronto. And I study exoplanets, which are planets around other stars aside from the sun. So if you have questions about that specifically, please let me know. But in terms of this question, is the universe expanding? Yes, it is. So when we look at faraway objects in the night sky, we see that they're actually getting further away from us over time. So what does this mean, for the end of the universe? Some astronomers think that this means things are just going to keep expanding over time, and we're going to end the universe in this kind of big rip where everything just kind of expands and rips apart in the end.
Cool. So we have another question, another size type question. Is the red spot on Jupiter, does it always stay the same size, or is it getting bigger, or is it getting smaller? Anyone feel free to jump in.
Okay, I can take that one. I'm Ayushi, and I'm also a PhD student at the University of Toronto, and my research is about star-forming clouds. So these are these giant space clouds made up of gases and dust, kind of like Orion Nebula, where stars are forming. As for the question, we have seen the Jupiter's red spot becoming bigger and smaller over time. This is still ongoing research. It shrinks in some area, like from lengthwise or widthwise, but it's always changing. So again, we're not really sure. It's an ongoing science right now.
Cool, great answer. So we have another question here. So many questions. We won't be able to get to all of them, but how do we know what the Milky Way looks like on the inside?
That's a great question. I think I will take it. But before I will introduce myself, my name is Jing Luo. I'm a postdoctoral in the University of Toronto. My research is mostly about the pulsars, neutron stars, some type of very unique stars that conventional star explode and what's left over. That's the object I'm studying. But about this question is if we are in the Milky Way galaxy, how do we know the shape? How do we know it looks like? So we only know part of it because we're inside. We never traveled outside Milky Way galaxy. So we only see part of our galaxy. So the image, beautiful image is showing this is the Milky Way galaxy is most like the other galaxy, or the artist's representation of our galaxy. It's not our Milky Way galaxy. But how do we know it looks like that? It's basically by studying the Milky Way galaxy materials where things located. We know things are located in the disk, and we know most mass has distributed in the arms. So that, and we observe other galaxies and make analog. Our galaxies must looks like the other one. So to answer for short, we never know how it looks exactly because we can't travel it outside the Milky Way yet. But from the information we learn from our observations, we know how it looks like. We can imagine how it looks like.
Ah, excellent. We have another question here in the chat. how do we know how far away stars are? How can we measure? How do astronomers figure out how far away stars are?
Okay, so I guess there are many ways to figure out. Like the closest stars we can tell by a method called parallax, which what it means is kind of like if you put your thumb out and close one eye, your thumb moves, and then you close your other eyes, your thumb moves again. It's kind of the same concept we use when we look at stars, but with Earth moving around the sun. So based then we can see how the stars are moving, and using some trigonometry and math, we can actually figure out how far the stars are, and that's for the close stars. For further stars, we use various other methods, looking at specific stars which grow bright and dim at a different period, and as we go further and further, there are various methods.
Cool, thank you, Ayushi. We have so many questions. I'm having a hard time keeping up, which is amazing. You guys want to know so much. How many exoplanets have we discovered? This might be one for Emily, but once again, if anyone wants to jump in, feel free to.
Yep, I can answer this one. So we currently have discovered a little more than 4,000 exoplanets. Wow. The cool thing is a lot of these exoplanets are totally different from the planets in our solar system. So we've heard a bit tonight about the gas giants in our solar system and other planets in our solar system. But a lot of these exoplanets that we've found are actually completely different, which is really exciting.
Cool. Wow. Even I didn't realize there were so many. So let's see. Here's an interesting one. Does every star in the universe or galaxy have at least one planet?
I can answer this one again. So they probably don't all have one planet, but on average, there is probably at least one planet per galaxy, or per star. Sorry. So yeah, we think that most stars do have planets around them, and most of them probably have more than one planet around them.
Cool. Just go through the chat here. And now here's a very basic one, and maybe we have a lot of younger folks watching tonight who are interested. What's it like being an astronomer? What's the best? And maybe we can go around quickly, and maybe we'll start with Jing on this one. What's your favorite part about being an astronomer? What do you like best?
Oh, there are a lot of things I like being an astronomer. But first, I think it's pretty cool that a lot of people like astronomy, and so I can sit here and talk to you guys, and that's something I really love to do. They use my own knowledge and tell people what we found in this a big universe. And the other things like I can use the most cutting edge instruments to do our researches. Like, we use the biggest telescope in the world to observe. We even use space telescope. So that's something I often brag about it. And also, we got a lot of chance to meet these great people. For example, being an astronomer in U of T, I got a chance to meet the Nobel Prize winner. They give us talk. I can talk to them. That's something like I never saw it before, but this is just a really amazing experience.
Cool. How about Ayushi? What do you like best about being an astronomer?
So I actually really enjoy just looking at the night sky, and that's kind of the reason why I got into astronomy. And when you see a bunch of nebulas and these big star-forming regions, kind of the image in my background, I work with these images, so seeing them every day, it's pretty fun. Also, just talking to everybody about astronomy and getting everyone hyped up, it's really enjoyable.
Cool, excellent. And last but not least, Emily.
Yeah, so for me, like I study exoplanets, these other worlds, and I think it's just so fascinating to get to really be the first person to discover things about these other worlds. It's almost like something out of science fiction, which I think is super cool. Another kind of perk for me, I guess, is the travel. So we get to travel to these telescopes that are all over the world. Obviously, Toronto is not always the best place for looking at the stars, so we use telescopes all over, and we get to sometimes go to those places.
Awesome. So we have another question here, and anyone is welcome to jump in once again on this one. What is inside a nebula? What is it comprised of?
Okay, so I'll take that one.
Perfect.
Nebulas are usually made up. They are made up of gases and dust. By dust, we means it's a compound of like hydrogen, carbon, sometimes silicon, and gases are like hydrogen gas, carbon monoxide, ammonia, and inside those clouds, they are actually very cold but also very dense, and eventually we will have stars inside them, and sometimes we have like bunch of stars forming together. So Orion Nebula is a really good example for that because it's an active star forming regions where stars are currently forming. So yeah.
Cool. Here's an interesting one. Can something like the Big Bang happen again? Ooh, sounds scary.
Well, this is a very interesting question. I think I will take that. So Big Bang happened once, and because of how universe work, the Big Bang stars and universe is accelerating, expanding. In our universe, at least with our current knowledge, we don't think there's another Big Bang. Hopefully. But maybe we'll be wrong in the future. So we should keep our eyes open.
Excellent. Now, somebody is asking, what is the largest black hole and how do we know how big it is? A lot of questions about black holes tonight.
Yeah, I think I can take that question.
Sure, go ahead.
Of course, if Ayoshi and Emily wanted to add on this, please agree. So the biggest black hole, it's already in the million times of solar mass, which is the mass of our sun, is a million times of that. So we call it a supermassive black hole. For example, in the black hole in our center of our galaxy, it's a supermassive black hole. So how do we know how heavy it is? That's a very good question, because what we do is we measure the stuff orbited around it with Newton's gravity. Think about it. Or adding this general relativity correction, we can actually measure the gravitational pull of the black hole, which we can infer the mass of the black hole. So it's not directly measured black hole mass, but indirect through this orbit of the other objects.
Cool. No, great answer. And here's another one. And once again, anyone feel free to step in. Is it true that the sun is getting larger?
So I can take that one. The sun is expanding in a very, very small way because inside the sun's core, it's fusing hydrogen into helium, and helium is helium is producing more and more energy, so it's actually blowing up, but not very fast. Eventually, it will become really big, like a red giant, but we are good for now. Yeah, but it is getting bigger at a very, very slow rate. So we're good for many, many, many years.
Many years. That's a relief. So we have so many questions, and they're moving so quickly. Is there any possibility that there's more than one galaxy? Do we know for sure everything we have, is that it? Or is there the possibility that there could be more than one? Anyone feel free to jump in.
I'm just so excited to jump in. So it's a great question. Is there any more galaxies other than our Milky Way galaxy? It turns out, if you go to some north part of Toronto or somewhere like quite dark, you can see another galaxy using your own eyes. It's called Andromeda. So there are a lot more galaxies. There's so many more galaxies, we can't even count them, but there's one, like another galaxy, you can even see it.
Cool. And here's an interesting question. A few questions about aliens and other life forms, but somebody is asking, would Mars potentially be a suitable place for humans to live, or someone to live, another life form, maybe not humans, maybe anything living? Anyone feel free to jump in.
Yeah, so in terms of humans, right now it's probably wouldn't be a very friendly place to live. But people do talk about terraforming Mars. So this means kind of changing the climate there and the atmosphere there and kind of different properties of the planet to make it more friendly for us to live there. But that would take a very long time. In terms of other life forms living there, there's definitely evidence that there has been liquid water there before. And some scientists do think perhaps there was maybe bacteria or some kind of life form like that there in the past. So it's definitely possible, but we don't have any 100% concrete proof of that right now.
Cool. Excellent. And I know there's so many questions we didn't get to, but I think we're going to wrap up our Q&A. So thank you for everybody who submitted questions. You can always find us on Instagram or Twitter, or our Facebook group, or you can email us at dunlap.utoronto.ca. If you have questions, we're always here. So I'd love to thank Emily, Ayushi, and Jing for being on our panel tonight. Wonderful all-star panel. Thank you so much, guys. And have a good night. Enjoy the rest of the planet party.
Thank you.
Thanks so much, Kara.
Thanks.
All right, sorry about that, guys. I had myself muted, but I want to welcome you all to the second round of games. This is round 2, Planet Party games. My name, once again, is Dr. Ilana McDonald. I work in the David A. Dunlap Department for Astronomy and Astrophysics at the University of Toronto. And so this is the second of our 3 rounds of games that we're going to have during the Planet Party. So we already had 1 round earlier, and there will be one more towards the end of the stream. So to repeat the instructions for those of you just tuning in, for each round of games, we're going to have prizes for the top 3 scorers and 1 prize for 1 randomly selected participant. So on your screen right now, and I see many of you have already figured it out, you should be able to see a giant number. So go to kahoot.it, so that's KAHOOT.it, or join with the Kahoot app and enter this game pin that you see on your screen. So 495-6604. So I'd recommend, once again, using a different device or browser window from the one you're watching the stream with, as the questions won't appear on whatever device it is you're using to answer the questions. Once you enter your PIN, you'll be prompted to enter an email address. If you don't want to give us your email address, that's okay. But know that only participants who enter their correct email address will be able to participate. Who participate will be able to get a prize. So if one of the top 3 scorers has not entered their email address, we'll go to the next highest scorer on the list who has included their email address. So I'd also like to note that you can only win once during this stream. So if you placed in the top 3 last time, you're not eligible, unfortunately, to be awarded a prize this time around. Also, we can only mail prizes to Canadian participants outside of Quebec. So if you're an international or Quebec participant, you can still place in the top 3, but if you do, you'll be awarded a one-on-one tutorial with how to take an astronomical picture using the iTelescope network with a real astronomer, which sounds pretty cool to me. So keep in mind that while you're playing the games, there is a couple of second latency between our games and the stream, so be sure to get your answers in really quickly. You're going to have 60 seconds to answer each question, but if you answer very quickly, you get more points. So make sure you're answering those questions as quickly as possible. So let's get started with round 2. And for those of you still joining, you can still join. The pin will be at the bottom of the screen. So as we get started, I would like to show you our prizes that you can win for round 2. So let's wait for that to come up. Here you can see all of the wonderful things you can win for the second round of games. So in the first place, you've got the Celestron Skymaster binoculars, which are really fantastic binoculars that you can use to look at planets. Everything that we've looked at in the stream so far, you can look at with these binoculars. Second place is a beautiful little Celestron First Scope. And in third place, there's a Dunlap Institute t-shirt, which is very attractive. And we will have one randomly drawn participant who will win a moon globe, which if you tuned in at the very beginning of our stream, Mike Reed had one in the background. So there's a cool little moon lamp. All right, so without further ado, let's get started on our questions for round 2. So our first question of the night. Approximately how long does it take light to travel from the sun to its furthest planet, Neptune? So Neptune is the farthest planet from the sun in our solar system. How long does it take for light to get from the sun all the way out to that planet? Is it 30 minutes? Is it 4 hours? Is it 2 days? Or does light travel instantly to Neptune? So you've got about 30 seconds left. Get those answers in. Remember, the faster you answer, the more points you can get. Got about 20 seconds left. So how long does it take light to travel from the sun to its furthest planet, Neptune? Got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and time is up. So let's see how you all did. So most of you answered 4 hours, which is in fact the correct answer. So for example, if you were traveling, sending a radio signal, which travels at the speed of light, 4 hours to get there, and then 4 hours for a response to be sent back. Neptune is about 30 times farther from the sun than the Earth is. So it's very, very, very far from the sun. All right, let's see how we're doing on our scoreboard. It looks like Mighty Lion is in the lead with Rapid Frog and Eager Sphinx closely behind. Let's see if you can get the next question and catch up. So our second question is a true or false question. Over half the missions to Mars have failed. Is this true or is this false? So over half the missions to Mars have failed. So in this picture, we have one of the missions to Mars, which was a success, the Curiosity rover. But have over half the missions to Mars failed? Is that a true statement or a false statement? So we've got about 30 seconds left to answer. Make sure you get those answers in quickly. About 20 seconds left. See, a lot of you are still answering. The faster you answer, the more points you get. So we've got about 5 seconds left. 4, 3, 2, 1, and let's see how you did. So most of you answered true, and this is in fact correct. There have been over 50 missions that have gone to Mars or have, tried to go to Mars, but over half of them have failed. But still, a lot of missions have gone to Mars. It's in fact the most visited planet in our solar system besides the Earth. Let's take another look at that scoreboard, see how everyone's doing. It looks like Eager Sphinx has rushed into the lead, followed by Rapid Cat and Mighty Unicorn. Let's go on to our next question. So on which body in the solar system is the tallest active volcano? So is it the Earth? Is it Mars? Is it Venus? Or is it Io, which is one of the moons of Jupiter? So which body in the solar system has the tallest active volcano? Is it the Earth? Is it Mars? Is it Venus? Is it Io, a moon of Jupiter? Which one of these has the tallest active volcano? The key word here being active. So we've got about 25 seconds left. Get those answers in quickly. About 15 seconds left now. Which body has the tallest active volcano? Got 5, 4, 3, 2, 1. Time is up. Let's see how you did. So most of you answered Mars, but the answer is in fact the Earth, and the key word here was active volcano. So Mars has the tallest volcano in the solar system, the Olympus Mons, which is 21.9 kilometers high, which is super tall. It's in fact the tallest mountain in the solar system, but it is not an active volcano. And Io is the most volcanically active body, several volcanoes going off at any one time, but none of the volcanoes on Io are taller than the tallest volcano on Earth, active volcano being the key word here, which is the Hoyos del Salado in Argentina, the tallest active volcano in the world and in the solar system. On to our next question, but first let's see that scoreboard. It looks like Groovy Finch has gone into the lead with Polite Dingo and Magic Crab behind. Let's go on to that next question. So who was the first astronomer to observe the moons of Jupiter? So here's a picture of Jupiter with its moons, or at least the biggest of its moons. So who was the first astronomer to observe those moons? Was it Galileo? Was it Copernicus? Was it Newton? Or was it Herschel? So if you've been listening to the stream, you might have heard this answered a little bit earlier. You have about 35 seconds left to answer. Who was the first astronomer to observe the moons of Jupiter? So you've got about 25 seconds left. Get those answers in. Was it Galileo, Copernicus, Newton, or Herschel? So we've got 10 seconds left. 5 seconds left. Make sure to answer quickly. Remember, the faster you answer, the more points you get. And the scores are in. Most of you got it. It was, in fact, Galileo. So in the early 1600s, Galileo observed Jupiter with his telescope, saw those 4 little dots, which were the moons of Jupiter, which we now call the Galilean moons. And this was, in fact, some of his observational evidence for a heliocentric solar system. Let's see how our scoreboard's looking. It looks like Groovy Finch is still in the lead with Polite Dingo in second place, and Focused Camel has moved into third place. So now for our final question of round 2, which is the smallest planet in the solar system? Is it Mars? Is it Pluto? Is it the Earth? Or is it Mercury? Which is the smallest planet in our solar system? So here we have a nice little picture of all the planets in the solar system. Quick note, though, it's not to scale, so don't use that for a reference necessarily. We have 8 planets in our solar system that you can see here. And which one of those is the smallest? Is it Mars, Pluto, Earth, or Mercury? We've got about 25 seconds left. Make sure you get those answers in quickly. About 10 seconds left now. So smallest planet in the solar system, last chance. And let's see how you did. So Most of you got the answer correct. The smallest planet in the solar system is, in fact, Mercury. And I see a lot of you picked Pluto, but Pluto is not considered a planet in our solar system. It's considered a dwarf planet. So Mercury is, in fact, the smallest of the planets in our solar system. So that was the last question for round 2. Let's see how you all did. In third place, we have Royal Pony. Congratulations. In second place, we have Focused Camel. Good job. And in first place, our grand winner for round 2 is Polite Dingo. Fantastic. Good job to all our participants. Congratulations to our top 3. Remember that if you put your real email address into Kahoot, you're eligible to win one of our prizes through a random draw, a really cool moon globe. Thank you all for playing for round 3. I'd like to say now that we're soon going to be joined by Professor Renee Hlojek, who will guide us through some observations of the planets Mars and Uranus, which are just rising right about now. But first, we have a really interesting talk to get us warmed up. So you're going to be hearing from Adam Barker, who's a PhD candidate in the Department of Classics at the University of Toronto, and he's going to be telling us a little bit about how the moons of Uranus got their names. So we're going to go on to that, and I'll see you once again for round 3 of games. Enjoy!
Hello everyone, my name is Adam Barker. I'm a PhD candidate in Classics at the University of Toronto. The Dunlap Institute has asked me to give a brief talk about the discovery and naming of Uranus and its moons, and that's what I'm here to do. Uranus is a bit of a weird planet in terms of its name, since it was discovered much, much later than the other 6 before it. Even though ancient astronomers in the Mediterranean could see it with their naked eyes, it didn't appear to be one of the wandering stars like the other 6, and so they paid it little attention. It wasn't until the 18th century that astronomers realized what kind of object was in the night sky, and it wasn't until much later than that that the name actually stuck. But for our purposes, this begins with William Herschel. Herschel was a German-born English astronomer who discovered the planet Uranus in 1781 after monitoring the northern sky with a telescope that he designed himself. Herschel had been an astronomer by hobby. His training had been in music, and since he was a philomath, or someone who liked to learn for fun, he exposed himself to a lot of scientific ideas. Scientific instrument making had also been a hobby of his since his childhood, and after he read a lot of scientific and philosophical books, he decided to join the astronomical community. Initially, after many nights looking at the sky and confirming that a bright light in it was actually moving, Herschel believed he had discovered a comet, even though he couldn't see its tail and neither could anyone else. Herschel reported his findings to the Royal Astronomical Society in England. They verified what he had seen, but realized that Mr. Herschel had not discovered a comet, but in fact had realized this was a planet. So the honor of naming it fell to him, and naturally, he settled on that name we all know, the Cetus Georgium. See, the convention of naming celestial bodies after figures from mythology hadn't actually caught on yet in the modern era. When Galileo had discovered the moons of Jupiter in 1610, for example, he had called them collectively the Sidera Medicaea, or Medicean stars. He did this in hopes of securing patronage from the Medici family. Now, shockingly, that name did not catch on outside of Italy, and so the moons of Jupiter were accustomed to being called by other astronomers the Galilean moons. When referring to a specific satellite, one would do so by number from proximity to the planet outward, so from Jupiter, 1, 2, 3, and 4. So, when Herschel was tasked to name the planet that he discovered, he followed this scheme and named his planet after his reigning monarch, George III. No one outside of England liked that name at all. So, in 1782, the German scientist Johann Ehrlich Bode proposed the name Uranus. Bode had reasoned that, since the planets' names, in mythological terms, ascend from son to father outside of the Earth, from Mars to Jupiter to Saturn, Uranus was the next logical choice. This was according to the scheme of the ancient Greek poet Hesiod's composition, the Theogony, which lays out the genealogies and wars of the ancient Greek gods. If you ever have time to read it, I do suggest it. There's a lot of lists of names, but there's a lot of very cool things in there as well. But the name Uranus didn't immediately catch on either. This was probably because using mythological names for new discoveries was somewhat taboo for, you might not guess, political reasons. Even though we don't think much of it today, naming moons was a massive deal back then. In fact, in the 17th century, a contemporary of Galileo's named Simon Marius had claimed to discover the Galilean moons before Galileo did. It was Marius who suggested naming the moons after mythological figures. Since the new moons orbited Jupiter, Marius and Johannes Kepler thought it would be funny, and seriously, they write that they did this as a joke, to name the satellites after figures who orbited Jupiter in mythology. So they chose 4 of his most famous love affairs: Io, Ganymede, Europa, and Callisto. But these names didn't catch on quickly because using them was seen as a defense of Simon Marius and a rejection of Galileo. Galileo claimed that he was the one who discovered the moons, and most people were inclined to believe him. So if you used Simon Marius's names, you were explicitly rejecting Galileo, and most astronomers refused to do that. So this brings us to an odd point, with inconsistent and politically dangerous names. Herschel still sticks to the name Cetus Georgium, Bode uses the name Uranus, and other astronomers are sort of caught in the middle. Making matters worse, the moons also become an issue because between the years 1782 and 1789, Herschel believed he had observed 6 satellites orbiting the planet that he had discovered. So he submitted his findings to the Royal Astronomical Society and named the moons, in Galileo's scheme, outward from the planet, 1, 2, 3, 4, 5, and 6. His observations, though, were incorrect. No matter how much Herschel insisted that he had found 6 moons, no one could find more than 2. Only those bodies he had designated 2 and 4 could be confirmed. The rest were, at best, invisible and more likely non-existent. So, understandably, astronomers were a bit grumpy. The 7th planet now had competing names, and none were consistent. Now it had 2 moons named, of all things, 2 and 4. So in the midst of all this confusion, people began to discover that Simon Marius hadn't actually plagiarized Galileo, and so they became better disposed to mythological names for satellite bodies. In the years following, the name Uranus caught on, but the moons remained a problem. No one could verify that there were only 2, no one agreed on what they should be called. So it wasn't until the year 1851 that the moon issue became settled. In that year, William Lassell discovered 2 more genuine satellites of Uranus with entirely different properties to those that Herschel had described. After this discovery, Lassell was able to name the moons, and he asked Herschel's son John to help. So, John Herschel selected the names of Uranus's moons, which are still in use today, but he didn't choose them from Greek and Roman mythology. There was a bit of a problem, since even though Uranus was the father of Saturn, Uranus was a sky god. And in Greek and Roman mythology, that sky god Uranus's children, the Titans, had already been applied to Saturn and its moons. Since Uranus, unlike Jupiter, didn't have any lovers beyond the Earth and the Night, which, you might realize, are names that we use for other things, some other name from some other source than Hesiod's would need to be chosen. So John reasoned that a name and a planet associated with the sky would have divinities of air surrounding it, and so he settled on names from British fairy folklore: Titania, Oberon, Umbriel, and Ariel. The first 2 names come from Shakespeare's play A Midsummer Night's Dream. There, Titania and Oberon are the queen and king of the fairies, who, in the play itself, are involved in a fight, using mortals as a proxy for their marital quarrels. The names Umbriel and Ariel were selected from Alexander Pope's poetry. Ariel is a sylph, a guardian sprite of the air, and Umbriel is her counterpart. Nearly 100 years later, in 1948, Gerard Kuiper discovered a new satellite orbiting Uranus, and, after some consideration, named the moon Miranda after a character from another one of Shakespeare's plays, The Tempest. And so, to this day, the names of Uranus's moons are taken from English literature rather than Greco-Roman mythology. This has opened up the door for a more inclusive, more varied nomenclature. With the restrictions of Greek mythology broken, names from all mythologies, from any culture, can be applied to celestial bodies. The stars, after all, belong to no one person, but to everyone. Anyway, on that note, I've been Adam Barker. Thank you to the Dunlap Institute for hosting this event and for inviting me, and thank you everyone for watching. Take care.
Hi and good evening. I hope everyone is having a wonderful time with us. My name is Renee Hlajek. I'm an assistant professor of astronomy and astrophysics here in Toronto. I'm sitting here in my home, but I'm a part of the Dunlap Institute and the Department of Astronomy and Astrophysics. We're having so much fun. I really hope that you're able to go outside if you can. I know that it's cloudy in some places, but really follow along with us. We have a super fun segment coming up where we're going to talk to you a little bit about what you can see in the night sky. So, if you have your devices and if you have a clear sky, please go outside and take a look. And we want to hear from you. Take photos. Let us know what the sky is like tonight where you are. Send photos back. And remember to use the hashtag PlanetParty2020 and to follow the Dunlap Institute on Twitter and Instagram. This is a super fun night and we're so glad you can be involved. Now, we have a lot of treats in store for you. Normally when we do this in person, we have a bunch of different telescopes set up that you could look through. And today we wanted to make sure we have the same thing. You enjoyed earlier looking through the telescopes at the Carr Observatory and here in Toronto at Jupiter. And so we have the same thing. So we have Mike Williams, who is at the University of Toronto. I know that we have a cloudy sky. And we also have Ian Wheelband, who is at the Carr Observatory. And I think what we should do is go first to Ian.
Hi, Renee.
How are you?
I'm very well, thanks. I'm sitting out here under a very cloudy sky. Clouds mean warmer, but, I can't see anything.
Well, one of the cool things about astronomers is they're always prepared, right? And so I know that you spent yesterday evening, which was actually quite clear and not cloudy, getting some treats for us. So why don't you tell us what we're going to look at?
Sure. So on the screen right now is an image taken facing due east at the Carr Observatory. And my mouse that you can see is actually due east right there. This light glow is from the town of Collingwood. And this creeping here on the far right side is the light pollution from Toronto. So you get a chance to turn your outside lights out that you don't need, turn them out. But the nice thing to do, and visible right now, if people have a clear sky to go outside, you'll notice the brightest thing to the east, just above the horizon, very obviously orangey red, at least to my eyes it was, is the planet Mars. And there it is in all its glory, shining away and shining far brighter than any of the other stars. If you had a telescope, you could move to this little object there, which is the planet we just heard about, Uranus. And it doesn't look like very much, so I won't say any more about it. But Mars, I think, is really, really cool. So let me just flip to a video of Mars that I took the other night. And at the end of that, I'll show a still image from that video. Because Mars although it's very, very close, very, very small. So hang on a sec. I just need to figure out what to do. Oh, it's gone.
While you're bringing that up, Ian, one of the things that folks, as Ian said, you can see Mars is pretty clearly orange in the sky. And it's one of the ways that we can also find planets is because they don't twinkle in the same way that stars do, just because the disk of the planet is a little bit larger. And so it's sometimes easier to find them because there's something in the sky that isn't twinkling the way you would expect for stars. So that's one way if you want to spot them later.
Right. Okay. So there, I've got Mars now. You should see Mars on the screen, and this is the video similar to what I did of Jupiter. And telescopes flip things upside down a bit. So this end is the south end, and this is the north. And if you look really carefully there in the wobbly image, it started to get windy last night. You can see that it's just a little bit whitish blue, a very small patch of light there. That's the south polar ice cap, which mostly carbon dioxide and grows and shrinks with the various seasons of Mars. But it's really neat to be able to actually see that, even with a little telescope. And you can see some of the surface features, and as Mars rotates, we see different features. So, so there's Mars through the video.
That's awesome. And we believe, Ian, that the features on the surface of Mars tell us something about how it formed and how it evolved, right? Because we see kind of riverbeds and different signs that there was once liquid water on Mars.
Yeah, very, very much so. And you know, I know when I first looked at Mars, I saw these slightly greenish areas, and I thought, oh, trees, grass. But no, sadly, no.
Right.
You're absolutely right. It indicates what perhaps was, not what is there now, I'm afraid. Sort of like deposits. So let me see if I can flip to, and I apologize for having to mess about a bit here, flip to the still image of Mars. Uh-oh, I closed you up.
One of the things
was...
that, again, while you're looking for that image, Ian, I'll just chat to the folks about, we think that Mars might have had a magnetic field earlier on in its life. And when that magnetic field, the dynamo stopped, then, of course, the atmosphere wasn't protected from irradiation by the sun. And so if the atmosphere goes, then, of course, the planet can kind of heat up and you can lose a lot of the surface water. But Mars is, of course, a hot topic right now because people are really interested in going to take samples from Mars and potentially investing as another human base. I think what people sometimes forget is that Mars is so much drier than the Earth when you talk about it being very dry. Oh, I see you've got you're still up there, Ian.
Oh, was it up there for a moment?
It was indeed.
Oh, I'm sorry. I'm having a little bit of trouble with showing some things here. So let's try that again.
Yeah. There we go.
Okay. So there's the still, and you can see the ice cap a little better. So what this is for the astronomer people or the amateur people wanting to take images, I use a very inexpensive video camera, which takes a minute or so of video that you just watched, and then through the magic of the computers, we get rid of all the moving atmosphere and the wobbling telescope and just add up all the sharp bits together so you can see the details in much better form. Ironically, that on a really good night, this is actually pretty darn close to what you can see through the telescope. Perhaps the colors are not quite so vibrant, but the detail is there without that.
That's awesome. So beautiful. And I know that there are lots of people who are interested about, telescopes and astrophotography. And in fact, we have a kind of Ask Me Anything later by Chris Vaughan on telescopes as well. So thank you so much. That's great. On a normal night that isn't cloudy, of course, what are the benefits of going to a dark site like the Carr Observatory compared to a place like Toronto? I mean,
well, probably one of the best things for me is that let me see if I can get there. Here's the Carr Observatory looking south for me last night, and you can see that it's you can see the Milky Way really beautifully. These are clouds here. There's our friends Jupiter and Saturn, but we get away from that light pollution, and so the objects that are normally completely washed out now become visible, and so there we have that Milky Way. This is the light pollution facing south from Toronto, which you can get away from, but even at well over 100 kilometers away, you can see how bright it still is.
Absolutely.
The other thing
that's a stunning picture.
The other thing that I really like, and let me go back to that first image that we had, and sorry. And here we are back to Mars and the tree in the east. The other thing that you can see in the darker skies, and it was referred to earlier by one of our speakers, this object here, which doesn't look like a star or doesn't look like a planet, and it is actually that galaxy, the Andromeda Galaxy, one of the furthest things you can see with the unaided eye. I find it interesting to note that, the trees there are maybe 750 meters, 1,000 meters away. Mars, we need to now start talking light time. I think it's like 40 million kilometers right now, or about maybe 4 minutes light time right from where it is now. And then Andromeda, about 2.5 million light years, or the distance the light would travel in 1 year at 300,000 kilometers a second. And if you get a telescope, this is what the Andromeda galaxy would look like if we had a telescope to have a look. And you can see peppered in front of all of the stars in our galaxy, this gorgeous galaxy there. And one might ask oneself, hey, wait a minute, this is a planet party. Well, with many, many stars in the 100 or 200 billion stars in this galaxy having planets, there's probably several billion planets in this picture, although we can't see them
Absolutely. And
individually.
I love galaxies too, so that's great.
Oh, me too.
And of course, one of the cool things is that in order for us to be able to see Andromeda, given that it's so far away, it of course has to be very, very bright. And so that's another thing to think of if you think of how many billions of stars are in that galaxy so that it's so bright we can see it so far away. Thank you, Ian. This is fantastic. This is really great.
Pleasure.
Wonderful. So I think what we will do is we'll also pop over to Mike Williams at the top of the physics building in Toronto just to have a chat. I know it's cloudy, but I know that Mike also took some great footage and he can maybe talk to us. So Mike, how are you doing?
Muted Mike, unfortunately.
Oh, I can't hear you, Mike. If you could unmute, that would be great.
Okay. Hi, everyone.
Hi.
So we're on the top of the physics building. We're looking east, and it's incredibly cloudy, unfortunately, tonight. So no looking at anything with the telescope tonight, but we do have videos from last night. So here's what the sky looked like last night when it was beautifully clear. So the really, really bright thing right at the bottom on sort of the right-hand side is the top of a building. Then that bright dot just up and to the left from that is Mars. And then there's a really, really faint dot to the right and down a little bit, and that's the planet Uranus. So the planet Uranus was the first planet. There we go. Was the first planet discovered using a telescope. Every other planet before that was so bright that people just had to look up in the sky, and they saw these bright dots moving in the sky. But Uranus was actually found using a telescope, even though it is technically bright enough that someone with really good eyes from a really dark place could actually see it. And this is a live view through our telescope. So it's very, very faint. So looking at it on a video, it doesn't actually come out really well. And in fact, it looks kind of green. And Uranus itself is actually very, very blue.
That looks awesome, given how small and far away it is. That's fantastic. Sorry, go ahead.
So the reason it's green is because of the way the camera works. So the pixels that make green are actually more sensitive than the pixels that make blue. So when you're looking at sort of very, very low light levels, the green pixels end up flooding it out. But I took a picture of it. So I took a picture for, I think it was about 8 seconds or so. And that's what Uranus looks like through our campus telescope.
Very cool. And of course, in the image of the video, we also know that there's the seeing basically makes the image move around a little bit as well, right?
Yeah.
What is the seeing in Toronto typically compared to, say, a darker site?
So it's actually a lot worse. So the downtown buildings actually emit a lot of heat. And so when you're looking out over those buildings, you can think of it like looking at a highway on a hot summer's day, and you can see all these wavy vapors coming up off the surface of that highway. It's exactly the same with all the heat coming off the buildings. And from our location, we actually have a smokestack, which comes from the heating plant for the entire university, and that puts out this giant plume of hot air, which just makes things look fuzzy when you look into that plume.
Not ideal. Stuck right in the middle. Do you have some more footage for us?
So that is what I have for Uranus. I can quickly show you what Mars looked like last night for us. So it's pretty similar to what was we saw out at the Car Observatory. So at the top there's that little white bit, which is the polar cap of Mars.
So awesome and so critical to understanding, as we said before, its history and how it was bombarded by other objects in the solar system as well.
Yeah.
That's fantastic. Now, the view from the telescope is also that you have quite a wide view compared to Ian's telescope as well. What telescope do we have at U of T, and tell us a little bit more about it.
Okay, yeah, so right behind me is our 8-inch refracting telescope. So refracting means it uses lenses to focus the light. So it has a lens that's 8 inches or 20 centimeters in diameter, which focuses the light down to a point. And I think in terms of field of view, the big difference between me and Ian is I'm actually using a camera with a bigger sensor on it. So I'm using Canon T6, which is just a commercially available DSLR camera to image with.
And I should give a shout out to Mike, who also coordinates a lot of our really cool exercises for our Astronomy 101 and 201 courses, where students can actually go and take pictures of the sky. And he's a total astrophotography whiz. So thank you so much for sharing this with us. Fantastic. So just a couple of more reminders, folks. We have a lot of games after the talks. And if you are at a site that can take a picture of the sky, we really want to see what you're seeing. Use the hashtag PlanetParty2020. We want to know where you are and how you're enjoying the sky with us. We've had a lot of talk about as planets and things in the sky that are from nature, but of course we're also interested in seeing things in the sky that are man-made. And one of the fun things to do, even when it's you're at a bright site, is one of the things that is really bright are satellites. And in fact, in a little while, in a couple of minutes, we're going to have an Ask Me Anything. Chris Vaughan is first going to tell you how to find satellites and how to look in the sky. And then we're going to talk about telescopes and how to use them. Get your devices ready for the Kahoot games. We're going to have another round of those. And let us know what you thought of this. Let us know about sites that you've been to. Tweet at us and tell us some of your best astrophotography stories and your best stories of looking at stars. We're really excited to hear all about you. And with that, we'll go to Chris.
Thanks, Renee. Here we go. Hi, everybody. My name is Chris Vaughan. I am a local astronomer, a member of the RASC, and I also travel to schools with a portable planetarium. So I do lots of fun things with astronomy. And I want to spend a few minutes talking about how to see or how to predict satellites. I'm going to share my screen with you so you can see my monitor here. And you should be PowerPoint presentation. So a couple of really useful ways to see predicted satellites are to use a couple of websites. One is called spotthestation.nasa.gov, but the one that myself and most of the people I know use is heavensabove.com. And see if I can bring that up and show you how that looks. Have you seen that, I hope? So in heavens-above.com, there's a dialog in the upper right corner where you enter your location, and you can type in your latitude, longitude, search for your city name, and so on. I've put in Toronto here. And then you've got a list of variety of options, and one of the ones that most people are interested in is the space station, the International Space Station, ISS. So if you click on ISS, it'll give you, for this location, the times and dates when the space station will fly over your location. It'll give you the time it rises or first appears, when it's highest in the sky, and then when it's low again. And you can see that the brightness of the space station will be indicated by its magnitude value, and a large negative number means it's very, very bright. So you can see we've got on September 12th a minus 3.9, which is extremely bright, almost as bright as the planet Venus, and you can't miss it. It'll take, most of the time the space station takes several minutes to cross the sky. And so if you're seeing something without blinking lights, because if it's blinking lights, it might be an airplane, but the space station and other satellites won't blink. They don't have lights on them. They're just shining by reflected sunlight. So you can look down the list here and pick a pass that you think is a good one. You can see that for the first few days of this week, we're going to have passes only in the pre-dawn. So satellites are only visible before sunrise and after sunset because they're still seeing the sun, even though it's gone below the horizon for those of us on the ground. And it's reflecting that beam of light down to the surface. So here's a good one later in the week on the 17th, minus 3.9. If you click the date, it'll show you a star map of where the where the space station will go. So it'll rise in the southwest, it'll slowly traverse the sky, and then when it gets to about the zenith overhead, it's actually going to move into the Earth's shadow and be lost. The sun will no longer be shining on it, so it'll go dark, it'll go dim, it'll go dark on it. So you can go through the different list of passes and see what's good for you. The tip here is to look for the ones with a high maximum altitude. That's how high they get in the sky. So 74 degrees is nearly overhead. And if you want to go to this one, you can see that it will pass nearly overhead of the sky. So heavens-above.com. The other thing you can do is use an app. I don't think my app screen sharing is working right now, but a couple of apps that are really good that I recommend are the ISS Detector app. And that one is great because it lists you a set of the upcoming passes of not just the space station, but it even covers the planets, comets that might be visible. You can search for different types of satellites and things like that. And then it'll alert you with a notification when it's passing. And it'll also show you a schematic view where you can tilt your phone and move the direction to put a dot on a bullseye, and that should then show you, your phone should then be pointing at the space station or the satellite as it's passing. So it's highly recommended. The Orbitrack app is really cool. It's made by the same originators that produced the Sky Safari app, which is popular with astronomers and beginners. And it actually has a huge database of thousands of different satellites of different types. And it actually features an augmented reality feature where you can hold your phone up to the sky and see the sky beyond the display on your phone. And so it's really cool. All right, so I think that's good for that. Let's move on to telescopes. What I'm going to do is, so I know that people always ask me what type of telescope should they get. So I thought I'd just start with a few basics and then we'll take some questions after that. So first thing you want to ask yourself is, what objects do you want to look at with your telescope? Because that will control the aperture or the size of the tube of the telescope that you're looking at. So the aperture is the area of either the lens of the telescope or the mirror in the base. You can see I've got a reflecting telescope with a mirror in the base behind me here. And that controls how much light that can be gathered by the telescope and then concentrated into your eye. And so that the aperture is controlled by the diameter of the mirror or the lens. And just as a rule of thumb, the aperture or the performance of the telescope scales with the square of the diameter. So if you're thinking of choosing between a 4-inch telescope or a 6-inch or an 8-inch, let's take those numbers and square them and do a ratio. So for example, a 4-inch telescope or an 8-inch telescope will collect 4 times the light of a 4-inch telescope. So if you're looking at dim objects like nebulas and galaxies, you want a nice large aperture telescope. If you're looking at, the bright moon, bright planets, those are relatively easy to see with even a small telescope. And that kind of leads me to the next point, is where are you going to use your telescope? Because you might want to have something that's small and compact that you can put in a backpack or that you can take easily in the car to the cottage. And so you might consider a tabletop model or something with a tripod that folds up. But a lot of us veteran astronomers, we recommend people investigate the Dobsonian style telescope. I'll show you a picture of a Dobsonian telescope in a minute. And it's actually a big sturdy box that a telescope sits in, and it sort of rocks up, down, and left, right. And they're very simple to use. And they allow you to put a large aperture telescope on a very simple base that anybody can use very easily. Now, there's a question, I get a lot of questions from people that want to buy a telescope for their partner. You know, I want to get a special birthday or holiday present for my partner. And they've been looking at computerized or go-to telescopes. And really you want to ask yourself, are you technically savvy? So are you, you know, able to or happy to deal with reading manuals and learning how to set up the telescope? Because a go-to telescope first needs to be aligned to the stars. You tell it where you are, where you're located, and the time and date. And then you need to point it to a couple of prominent stars so that then it can interpolate between the bright stars and automatically show you the dim objects that are in the sky. And so they're great for using in urban environments where it's hard to see the objects without help pointing. But you know, it may not be appropriate for little kids. For a young family, you may want to start with a manual telescope where you push it around by manual, and then when you're ready to advance to a computerized system, you can go there. And finally, a lot of people ask about taking photographs through the telescope. So Jenna touched on that earlier in the session. And if you want to be seriously into astrophotography, then you really want to put your money into a good, sturdy mount or tripod. The size of the telescope isn't as important because the camera is doing the work of accumulating the photons over a long period. You're doing a long exposure photograph through the telescope. So the aperture is not as important for photography, but you do want very accurate tracking and very reliable pointing so that your images are, your stars are pinpoint and things like that. So Kara, we can take some questions, I guess.
For sure. Yeah, that would be great. A lot of people always have questions about telescopes. I guess one of the big things, this has been very helpful, etc. But so for a very beginner who doesn't know very much and they just kind of want to get their feet wet, like how much would you need to spend, or what would you say to somebody who's not sure, they just want to give it a try with telescope viewing?
So I've got actually a list here of some entry level and some more advanced telescopes, and people can take a screen cap of the URLs that I've got listed there, and then there's a range of price points and quality there. Remember that if you spend a little bit less, you're probably going to get a telescope that has a lot of plastic parts. And that's fine if you take care of it. But again, if you were dealing with young kids, or maybe you want to use it in the extreme cold weather, you've got to be careful that things can break or snap. I mean, this old workhorse behind me is from the 1970s. It's an old Tasco reflector that I've had for decades, but it's all metal and aluminum, and it's lasted for years and years and years. And a good quality telescope will last you a long, long time. You can also, if you take care of it, you can sell it, upgrade it. You can upgrade, sell it to somebody else. So you can spend as little as a few $100s for a plastic, a functional telescope that has a lot of plastic parts. But if you really want to get something of value, I would say try not to spend less than about $500. And then if you really want to get serious, you can go up and up and up. So some of the entry-level go-to computerized telescopes are in the $1,200, $1,600, $2,000 range. But, so it depends on, your level. And as I said, if you buy something that's a good quality and you decide later you wanted to go a different direction, you can always sell it.
Cool. Yeah, that's very helpful. So here's a very interesting one, and I'm actually quite interested about the answer as well. What is the difference between, binoculars? Some binoculars are marketed to say, for planetary viewing, but what's the difference between those and a telescope? And is there, one or another that's better, or does it depend on, what you want to see?
Yeah, so the beauty of binoculars is that they show a very large field of view of the sky, perhaps 5, 6, 7 degrees of the sky. And that makes finding objects easier because, you point it in generally the right direction, and chances are your object is going to be somewhere in the field of view. Whereas a telescope would only maybe show 1 degree of the sky, or even less if you magnify the image a lot more. But basically, binoculars and telescopes, it's the same principle. So you've got a pair of 2 smaller telescopes bolted together to make a pair of binoculars. It's just that the aperture of the lens at the front of the binoculars tends to be smaller to make them portable, and then they won't gather as much light. So It's a trade-off between convenience. Also, the two-eye viewing is often a lot easier for people. In terms of the aperture question that I mentioned before, I would stay away from a telescope that's smaller than about 80 millimeters, which is the sort of the number, the way they're marketed. So 80 millimeters, 100 millimeters, that would translate to, say, a 3.5-inch telescope or a 4-inch telescope, and up from there, if you really want to be able to see beyond the moon and planets.
Ah, cool. Excellent. And yes, that very much solves, I was always wondering that as well. Here's a bit of a more technical question. What is the best pixel scale for high magnification planetary imaging?
Ooh, I'm not an imager, so you'd have to go back to Ian for that. He's the imager of the group. I'm strictly an observation, a visual guy.
Okay, well, we can absolutely, we have the knowledge. We can get you that answer at a later time, John, who was asking that.
So let me just show you a couple other things.
Yeah,
while you're waiting, let me just show you a couple other things. So if you want to buy used equipment, you can save a lot of money. And if you buy from an astronomer or a RASC member, chances are it's somebody who's honorable and honest and has looked after their equipment. So one of the places that we often go to is this website called Canada-wide Astro Buy Sell. It's where we all check in to see what's for sale, and we also post our equipment there, eyepieces, telescopes, tripods, even cameras and things like that sometimes. You can use Kijiji, but of course there's a risk there with not knowing the person as well, and you don't want to meet strangers without due caution, of course. But if you are searching for Kijiji, my advice is to search province-wide, because if you're in Toronto, you might find somebody with a great deal in Oshawa, which isn't a bad drive, which you wouldn't normally get if you just focused on the Toronto site. In terms of buying vendors, I've got a list of vendors here in the Toronto and wider region. And one of the things I want to point out is that B&H Photo Video in Manhattan have a lot of telescope equipment, and they do free shipping to Canada and, over the border sort of shipping. So, you might even be, if you're watching from the States, and that's a great source.
Perfect. Good to know. And I think we do have a handful of viewers from south of the border this evening, which is fabulous. If you'd like to take another question, I've got another viewer question ready for you. How good of a telescope would you need to observe spiral galaxies?
So the Andromeda Galaxy that was mentioned a few minutes ago, you can see that with a small 3.5-inch, 4-inch telescope if you're at a dark location. So you want a moonless night, away from the city lights, and you can see that naked eye. You can see it in binoculars, and you can definitely see it in a telescope. If you want to go down from there to the more trickier ones, you can still see them with the 4-inch telescope or 6-inch or 8-inch. This one behind me is a 4-inch just for scale. But if you want to go for a bigger telescope, let me show you a picture of some models here. So down here on the lower right, this is the Dobsonian style. It's sort of the tilt and swivel reflecting telescope style. And that would be, looks like an 8 or a 10-inch diameter mirror. If you buy an 8-inch telescope, then you're going to be able to see quite a number of galaxies and nebulas with that. If you want to go a little more extreme, then you want to go even bigger. I have a 12-inch. Ian has a 20-inch.
Wow. That's how he was getting such fabulous pictures of everything. Wow. So here's a question that nobody has asked, but I think is important too. And if, let's say, somebody gets a telescope, they're really gung-ho, excited to try it, and they're just having a hard time. They don't know, they don't really quite know how to use it properly or get the most from their telescope. What do you recommend that they do?
Fantastic.
They need a little help. Yeah.
Yeah, so the secret weapon there are basically star parties and astronomy clubs. Now, in non-COVID times, the RASC holds twice a month star parties, once in the city limits and then once in a dark site when the skies are clear. And we don't always luck out, but we welcome anybody who wants to come and either look through our telescopes or ask us questions or even bring their own telescopes, and we'll help you set them up. And since we can't gather that way right now, then really it's a matter of connecting with the astronomy club and seeing, ask us on Facebook or on social media. Normally we're monitoring that and we can answer questions and maybe connect people up with an expert on their particular telescope and so sort them out.
Perfect. No, that's super helpful that there is help. You don't have to be alone if you're having a hard time with your telescope. Lots of great resources. Chris, we have about a minute left. Is there anything else that we really should know about telescopes that we haven't touched on that you'd love to share with us?
Yeah. So really the rule of thumb to be happy with your telescope is to buy the biggest aperture that you can manage or that you can afford. Of course, it's got to be big enough to put in your car or big enough that your partner doesn't mind it sitting in the corner of the living room, right? And some of them do fold up. But the bigger the aperture that you have, then the more your horizons are expanded. So there's that aspect of it. And the other thing is to try to buy a telescope. If you're buying a smaller one, buy one. Try to find one where the tripod is very sturdy and relatively heavier. And because there's nothing more frustrating than trying to focus a telescope and it's jiggling all over the place. So sort of those two, guidelines to help you choose your telescope. And happy shopping.
Perfect. No, that's great. And I believe with that, we are just about out of time for our sharing. So thanks everyone who asked questions. And thank you, Chris, very much for all of your expertise this evening. I think everybody learned a lot. Lots of people in the chat tonight, they're all dying to play more games. So I think we just may have one more round of games. So I think for one final time, we're going to bring back Games Master Alana McDonald to take us through one more round of games. If you haven't won a prize, you have one more chance. Be fast, get more points. And here's Alana McDonald.
All right. Hi again. Thank you for the introduction, Kara. Once again, I am Ilana McDonald. I work at the David A. Dunlap Department for Astronomy and Astrophysics. And this is round 3 of the Planet Party games, the final round. So we already had 2 rounds before this, and this is your last chance to play some games and win some amazing prizes. So if you just happen to be tuning in right now, on your screen you should be able to see a big number. What you should do is, if you want to join the game, the last games of the night, you should go to kahoot.it, that's KAHOOT.it, and enter that game pin into where it tells you to do it. So if you are using your device to watch this stream, you should probably be answering the questions on a different device or in a different browser window, because you won't be able to see the questions on the device which you're answering the questions on. So once you enter your PIN, you'll be prompted to enter your email address. We understand that sometimes you don't want to give out your email address, but you should know that you'll only be able to get a prize if you win, if you've entered a correct email address. So make sure that you're entering your correct email address if you want to be eligible for a prize. If one of the top 3 winners doesn't have their correct email address, we're going to go down the list to the next highest scorer who does. Unfortunately, we can only mail prizes to Canadian participants, so the actual physical prizes that we have will only go to Canadian participants outside of Quebec. However, international and Quebec participants will win who win one of the top 3 spots will get a 101 tutorial with an actual astronomer to learn how to take an astronomical picture using the iTelescope network, which is in its own right a very awesome prize. And so I'd also like to note that you can only win once during this stream. So if you won one of the last 2 rounds, you are unfortunately not eligible to win this round. So if you place in the top 3 this round and you've already won, then the prize will go to the next highest scorer on the list. So keep in mind that when you're playing the games, there's a little bit of a latency between me and what you see on the stream. So be sure to get your answers in quickly. You're going to have 60 seconds to answer each question. And remember that speed counts. So the faster you answer a question, the more points you get. All right. So let's get started with round 3. So here's our third round of questions from the Planet Party. Before we get to the actual questions, let's talk a little bit about what prizes you can win for round 3. So the first prize in this round is our very unique custom-made Chime Lego set. It's amazingly fun, very cool. The second prize in this round of games is this beautiful moon globe lamp. It's really, really cool. It's just this glowing moon that you can hold in your hand. You can place on the little stand, and it's very classy. And our third prize is a Dunlap Institute t-shirt, which looks very, very nice. And there will be a random draw for one participant who enters their email address, and that random draw will get that moon globe lamp as well. So if you put your name in and your email address in, and you didn't win, you're still eligible for that draw. All right, let's get started with our third round of questions. So for our first question of the round, how old is the light that we're now seeing from the Andromeda Galaxy? So when we look at the Andromeda Galaxy, how old is that light? So is it 100,000 years? Is it 2.5 million years? Is it 1 billion years? Or is it 13.8 billion years? So get your answers in quickly. The faster you are, the more likely you are to get more points and win. So you've got about 30 seconds left. So how old is the light that you can see in this picture, this beautiful picture of the Andromeda Galaxy? How old is the light that we're now seeing from that galaxy? So is it 100,000 years? Is it 2.5 million years? Is it 1 billion years? Or is it 13.8 billion years? So you've got about 10 seconds left. Get those answers in. About 5 seconds left. And time is up. So most of you answered 2.5 million years. And if you were listening in the stream earlier, you would have gotten that answer. So yes, the Andromeda Galaxy is the closest large galaxy to us. It's 2.5 million light years away, which means the light coming from it is 2.5 million years old, which means that you're actually looking at it as it was 2.5 million years in the past. So let's look at our scoreboard and see how we're doing. It looks like Expert Sloth is in the lead, with Proud Chicken and Bright Elephant closing in right behind them. Let's go on to that next question to see if some of you can catch up. So in Roman mythology, what was Uranus the god of? So this is the planet Uranus you can see in that picture there. Was Uranus the god of the ocean, the god of lightning and thunder, the god of the sky, or the god of the underworld? So in Roman mythology, what was Uranus the god of? And I should say, this is something you might have heard during Adam Barker's talk, if you tuned into that a little bit earlier. So was Uranus the god of the ocean, of lightning and thunder, of the sky, or of the underworld in Roman mythology? So you've got about 20 more seconds to answer that question. Get those answers in quickly. 15 seconds left. All right, we've got about 5 more seconds left. Get those answers in. So is Uranus the god of the ocean, lightning and thunder, the sky, or the underworld? The answer is the sky. So Uranus was the god of the sky. Neptune was the god of the ocean. Jupiter was the god of lightning and thunder. And Pluto was the god of the underworld. Good job. It looks like most of you got that correct. Let's see where we are on our scoreboard. Looks like Kind Meerkat has moved into first place. Gentle New has moved into second. Honest Finch into third. So let's go on to the next question and see who can catch up. So for our third question, we have, how big is the largest visible light telescope in the world? So there we have a nice picture of a telescope on a hill. How big is that largest telescope in the world? Is it 2.4 meters? Is it 8 meters? Is it 10.4 meters? Or is it 30 meters? So you've got about 40 seconds left. Get those those answers in. Is the largest visible light telescope 2.4 meters, 8 meters, 10.4 meters, or 30 meters? And that also is a very lovely image of a very large telescope. You have about 15 seconds left. How big is the largest visible light telescope in the world? Got about 5 seconds left now. And your time is up. So the answer is 10.4 meters, and it looks like most of you got that. The largest visible light telescope in the world is the Grand Telescopio Canarias, which is in the Canary Islands. Let's move on to our scoreboard once more. Let's see how you're doing. It seems that Bright Oryx is in the lead now, with Wonderlark in second place, Magic Mouse in third place, and many others coming up close behind. So we've got one more question to go for the night. This is our, second to last telescope question for the night. Which planet cannot be seen with the unaided eye? Or which planet currently visible in the night sky could not be seen with the unaided eye? So is it Uranus, Saturn, Jupiter, or Mars? So think about the planets that we've talked about this evening. Which one of those would it be very difficult to see with the unaided eye? And I should say specifically in a place with not ideal dark sky conditions. So is it Uranus, Saturn, Jupiter, or Mars? So which one of these is not currently visible with the unaided eye? So you'd probably need a telescope to view it. So you've got about 15 seconds left now. 10 seconds left. Get those answers in. Remember, the faster you answer, the more points you get. And we are just about out of time, and that is it. How did you do? Most of you answered Uranus, and you are indeed correct. Saturn, Jupiter, and Mars can all be seen very easily with the unaided eye. Even in Toronto, the city I live in, which has a lot of light pollution, and you can very easily see those, but you cannot see Uranus very easily. You have to use a telescope. All right, let's see how our scoreboard is looking. We've got Wonderlark in the lead now. We've got Elated Seal in second place, and Bronze Bunny following up very closely in third place. We've got one final question for the night. It is the last question that we're going to be doing, so be sure to answer it quickly. So which space probe is the only man-made object to have visited the planet Uranus? So which space probe is the only man-made object to have visited Uranus? Is it Pioneer 11? Is it New Horizons? Is it Juno? Or is it Voyager 2? So get those answers in quickly. This is your last question of the night. I know I'm very sad to have it end too. You've got about 30 seconds left. So which one of these space probes is the only man-made object to have visited the planet Uranus? Is it Pioneer 11, New Horizons, Juno, or Voyager 2? Got about 15 seconds left. 10 seconds left. Get those answers in, everyone. And we are out of time for this, the very last question of the night. So the answer to which space probe is the only man-made object to have visited Uranus is Voyager 2. It is, in fact, the only man-made object to have visited both the outer planets of our solar system, Uranus and Neptune. It visited Uranus in 1986, and it visited Neptune in 1989. And that's the only time that a man-made object has ever flown by those two planets. So let's see how you did for this final round. Let's announce our winners. So in third place, we have Cheerful Falcon. Congratulations. In second place, we have Wonderlark. Amazing job. And our grand prize winner for the third round is Elated Seal. Excellent job. Congratulations to our top 3 winners. Congratulations to everybody who played. Remember that if you put your email address into Kahoot, you're eligible to win that really cool moon globe through a random draw. So I want to thank you all for playing tonight. I had a lot of fun. I hope you did too. And now I'll turn it back to our host, Mike Reed. Thank you so much for playing.
Okay, thanks, Alana. And that's a wrap for our Planet Party 2020. I'd like to thank all of you for sticking with us through the evening. I hope you had a great time learning about astronomy, looking at the night sky, playing games, all of this good stuff. If you enjoyed yourself, please help us reach even more people with this great, completely free content by giving us a like or a subscription or leaving a nice comment for one of the many people who contributed to this stream. I want to thank, in addition to everyone who you saw on camera, there were quite a few people off camera who you didn't see, in particular, our communications officer, Megan McSween. So if you heard about this event, it was likely because Megan put it somewhere where you would have heard about it. So we're very grateful to her for doing that. We're grateful to all of you who shared the event and helped bring this to more people. We do this, as I say, completely for free because we just want to share our love of the universe with you. And every time you share or pass this content along, it really helps us reach more people. So thanks very much to everybody who contributed to this event. If you're interested in having more events like this, please do let us know. You can contact us on social media at Dunlap Institute on Twitter, Facebook, Instagram, all the usual places. You can comment on this video or you can chat something in the chat room. But we're done for tonight. Thank you very much, everybody. Stay safe and good night.